After. Welcome, thank you for coming. So my name is Alan Wolfen, that's me right here. So today, along with me, I've got my friend Joe Zara, sitting in the back, TCF. I call it W2AW. My initials, the vanity call sign, because I can get that in your license plate, the vanity call signs. I did that so that when I get old and stuff in my head, I can still remember my call sign. So anyway, this is all based on a study guide that was published in this document. So I found it's been a really good guide because this gives you enough to kind of get. I hate to say we're studying to pass the test, but really, in a sense, that's what this has to do. But some people will kind of view that and say, well, you're not really teaching, you're just studying to pass the test. So in my mind, once you get your license, that's kind of your ticket to start with. You don't have to do everything before you get it. To know enough to not hurt yourself or hurt anybody else or interfere with somebody, you just kind of follow the rules, and then you pick up the road from there. I learned something the other day. So that's the point. So this is kind of our rough agenda today. I'm going to take you through the first half or so of all of this, and then Joe will pick up from the second half of this. Take some breaks as needed. Any questions you have as you go along here, feel free to stop me. Myself and Bill should go answer anything that you've got. I've been licensed since I was licensed in high school, and so there's been licensed and would have longer than that. So we've been around the hobby a bit. Answer anything that you've got. So what is amateur radio? Amateur radio is, well, it's a hobby, yes, right? One of the things I did it is. It's also a service. Oftentimes, amateur radio folks are called upon to help out with communications or maybe events like a race, something like that, as well as in times of emergency with communication. That's a combination of hobby and service, and it's fun. That's why we do it. If we didn't enjoy it, we wouldn't do it. Right? So we don't get paid for this. So it really is what you make of it, right? And everybody gets something different out of it, and what you get out of it may be different today than what you'll get out of it 10 years from now, or next week, or next month. I don't know. Just me. Here for the HamCram? Yes. Okay, absolutely. Come on in. Just getting started. Slide page. Okay. So really, it's really all about communicating, experimenting, serving when that's necessary, interacting with other folks, and there's even competition aspects of this as well. So it is regulated. You've got to get licensed, the rules you got to follow, that kind of thing. But it's non-commercial. You're not allowed to make money with it, right? You can't run a tax exempt service with it or anything like that. But it's really designed to be a non-commercial. Experimentation is encouraged and allowed. So unlike some other radio services like Citizens Band Radio or the LFRS radios and things like that, you get the camping where you're not allowed to really do any modifications to those things. Amateur radio, you're allowed to and even encouraged to build drill equipment, do modifications, things like that, as long as what you're doing is still within the rules of what you're allowed to transmit at that time. Again, there is a community service aspect of it. If you're into that kind of thing, you want to help out with that, it's always a great thing to do. I've done these classes for community emergency response teams, for CERT teams throughout the state, because a lot of them will get their licenses, and again, if their own radio services go out, they've got something else to provide. It is a technical hobby, so a lot of the hobby is about technical learning and discovery and things like that, and you can get as technical in it as you want. Okay, you can just push buttons and little knobs and do things that way, or if you're into getting deeper technically, you can do that. And there are ways to compete. There are what we call amateur radio contests, which will have, sometimes different goals in mind, like how many different stations can I work in a certain time period, or how many different countries can I talk to in a certain time period, or under these operating conditions, what can I do, that kind of thing. And then there's ways of kind of competing and gathering scores if you're into that. I'm not a contester myself, not my thing, but there's other things that I do to challenge myself. And so it really is something for everybody. And again, it's going to be what you find just for necessity or fun. Okay. So lots of cool things to do. There are satellites circling the globe that you can communicate through, which is kind of cool. most of the astronauts on the space station are hams. And they'll schedule a time when they're across the country that they contact schools and things like that. That actually talk to astronauts. Pretty cool. So just flying around. But even radio controlled hobbies, there are license free radio controlled hobbies, but also radio ones that give you a little bit longer range. There are digital nodes that allow you to actually use computers to talk to people's computers on the other end, and radio in between, that type of thing. What we call phone, which is ordinary voice communication, but probably think of radio. There's telegraphy like CW, something I've been getting into the last 5 or 6 years. Home brewing, not home brewing beer, but home brewing your own radios. You don't have to know it anymore. So now it's a personal choice and a personal challenge if you want to do that. But, they eliminated the code requirement 15 years ago. So and we went from 5 license classes down to 3. So what we're talking about today is a technician class to get you started, and there's a general and extra of the other ones beyond that. Each one of them is just a written test. 35 questions for the first, 35 questions for the second, 50 questions. And you have to pass one to be able to take the next. And we've had people who come in here who are technical people and don't have a bunch of study. They come in here and start with nothing and leave with an next. And you'll find if you're sticking around for the testing session later, pass the technician class, they'll offer at no additional fee for you to take the next test up in general. And free look at it, doesn't cost you anything, and you've got the time to go through it, do it. And if since it's a multiple choice thing, you can pass, you come out here with a check. Okay. I'm sorry? I'd like you. Okay, absolutely. So and then we'll just keep moving forward that way. So lots of different aspects to it that you can get involved with. So we're going to kind of start working down through that agenda. The first thing we're going to chat about is the electrical principles. People have HamCram? Let's see. So I'm Alan, that's Joe. We're going to bounce back and forth with the no, we're actually just getting started. We just finished the review an hour and 8 minutes. And again, as I mentioned earlier, there really isn't enough time in the time we have here this morning and early this afternoon to teach everything. It's really more of to help you identify those areas, got some questions and things like that. We'll do any questions you have as we go along here. Feel free to stop me at any point. Again, we'll do some Q&A afterward. Finally, Noah will run through some practice exams that people just do kind of online, an online resource that might help raise some more questions. Various questions. So the first topic on our agenda is electrical principles, and there's some just basic electronics that you need to be aware of as we test. So first concept that we'll talk about is voltage. Let's go ahead and speak a decimal. Wherever you like. Yeah, no worries. So actually, we're just getting started here. So we're just did a little bit of a review up front. I'm Alan. That's Joe. Thanks for your pleasure. Thank you for coming. And so the first electrical principle we'll talk about is voltage. And I'll draw a little bit of a water analogy. So sometimes it's a little bit easier for people to kind of picture things that way. So we'll talk a little bit about that. Voltage can be thought of as it's the force that pushes electrons around conductors. So the more voltage you have, the more push you have, the more force you have. You'll notice also as I go through these slides, anything that I've got in boldface or italicized or underlined, these are typically words or phrases that will be in the questions. Okay, so it's just a good idea to kind of think, oh, okay, voltage, force, okay, that. It's also called electromotive force. That's where the term EMF comes from. So it's a force we'll call electromotive force. Yeah, maybe a question. It's measured in a unit called volts. 9-volt batteries, 9V, right? It's 9 volts, 9-volt battery. Okay. It's measured with a voltmeter. That makes sense, right? Well, that's just kind of common sense. And in equations, you'll see that the symbol that's used when we use equations, don't worry, is the letter E. That comes from electromotive force. So when you see an equation of how to compute things, you'll see the letter E as the symbol that is used in the equations, but the symbol that's used in terms of when we're specifying a certain voltage, a 9-volt battery, a 1-volt outlet, okay. And again, one question on the exam that might show up is that typical mobile radios that you put in the car operate on 12 volts, like most cars, except now that we're in the EVs, not everything's 12 volts anymore. Before EVs came along, everything was 12 volts. And before that was 6 volts. Okay. But again, these are just things that you may find these questions on the exam. There's some, a lot of it is just more common sense. Okay. So that's the first major principle in basic electronics. It's this concept of voltage, this push. So current is one of the other principles, if you will. The electromotive force and the voltage is actually pushing electrons through a circuit. So the electrons are what are basically flow of electrons is current. The more electrons that are flowing, okay, the higher the current. Okay. So the more voltage you have is pushing of electrons, you get more current. So you can think about it as like water through the pipe, right? The voltage is the pressure, the water pressure. The actual flow of the water is the current. And so if you cut the valve off and you're not getting the water out of your faucet, pressure's still there, right? But you have no current. So it's measured in a unit of amperes. Often we just shorten that to the word amps. The symbol is the letter I. It comes from a French word, something or other that is French. But the unit symbol that we use, we're saying, okay, we're going to circuit is carrying 2 amps. So I have a fuse that's rated for 5 amps. It's 5 amps. Right? But when we use it in equations, the letter I is used. And it's measured with an ammeter. We just take the P out of it. It's an ammeter. Okay. And then we'll see this term DC is direct current, meaning that in that circuit, current only flows in one direction. Conventional current flow is positive, even though the electrons flow. Well, conventional flow is positive. AC, or alternating current, alternates between flowing in 2 different directions. The wall outlet is 120 volts AC, right? Positive and negative. So batteries are DC. So alternating current, like we have in our outlet, yes, this is not upside down. It is actually how outlets are supposed to be. Were designed originally, they're supposed to be placed. They're supposed to look like a base. They were done this way, so if something conductive dropped down on top of them, round, instead of hitting the 2 conductors and shorting out. That one's back. They're all upside down. Everybody does them upside down, but that's the way they're actually supposed to. Electrical engineering, probably. So the frequency of an alternating current is the number of times per second that an alternating current completes a cycle. Goes positive, goes negative, goes backwards, start. Okay. So how many times a second it does that is the frequency of things. For us here in the US, our 120 volt outlets are 60 hertz, 60 times a second. In Europe, it's 50 hertz. So again, hertz is the unit of frequency. You used to say cycles per second. It's a lot more descriptive. Now they named it as Sky Hertz. So it's 12 hertz. So again, in the US, we've got 60 hertz AC power. So the third main principle in electronics, we've got a voltage push, we've got current that flows. So what restricts that current is something called resistance, right in the name. So think about that like taking down, a pipe or something like that, or cutting a valve on. So that's what opposes the flow of electrons. So a higher resistance, smaller amount of current. Okay. This applies to DC, to AC, to RF current. It's measured in a unit called ohms. Okay. The symbol, thankfully in this case, the symbol that's used in equations is the letter R, okay, resistance. But the symbol we use is the Greek symbol of A. Okay. So the way to think about that is, we'll use this desk as an analogy. So if I push on this desk, that'll put a lot of pressure on it. It's got a lot of resistance, so very little, no movement, so there's no current, right? I got to put a lot more electric moving forward to move that table, and the harder I push, the faster it moves, right? More current. So you kind of see the relationship. Increase the voltage, you can increase the current, or decrease the resistance. The wheels up, I can increase the current. Okay? So you see there's some relationships in there. That's what we get into next. We're going up to the measure of resistance with an ohmmeter. So that one. sense. We'll talk a little about the relationship here shortly. Let's talk about conductors and insulators. Conductors are things that allow easy flow for offer very little resistance. So copper wires, anything metal or metallic typically is a pretty good conductor. Okay, so low resistance, they allow current to flow, and typical metallic types of things. And emitting free electrons. Insulators, on the other hand, offer a very high resistance. Plastics, rubber, things like that, the coating that is around wires is because of their insulation, but a very, very high resistance, and no current flows through that. Okay. So plastic, wood, glass, mica, some of these materials may question. So here's that relationship. Got printed out right here is a very good thing to kind of almost memorize. Is this little mnemonic here. Voltage, current, resistance. And it's just got to draw it in a couple of different ways. This can be really handy to figure out the equation for the relationships. Talk about it. It really kind of describes that. Think about this. It's like, let's say I've got to compute a value of resistance. I know the voltage and I know the current, but I don't know the resistance. Cover up resistance with your hand. The equation is voltage and the current. Okay. So same thing, if I know the resistance and I know the current, how much voltage appears across that resistance? Cover up voltage, current times resistance. Okay. So we can kind of see just by covering up the thing that we want to find, we get the equation. So if you memorize this, think about it, you can look at this thing until they say, okay, it's time to do the exam, put that away. Get your scratch paper out, throw it down in the scratch paper. Now you have your own form. Okay. Okay. So voltage is current time resistance. So you got perfect. All right. So if you got a current flowing through some resistance value, multiply those two together to get the voltage across that.
I just didn't want to, interrupt. I am interrupting. I just wanted to leave you some flyers for the Moore project.
Okay.
The Moore project. Hey, the Moore project here. The Moore project is an initiative that was grant funded, and it's under the Daytona Radio Club. And I'm going to leave some business cards for the Moore project, which have the website. But if any of you don't pass the exam, we have a free course. And you will pass it if you take the course, but this course is great.
So if I don't do my job right and I suck, you'll see Rebecca should pass.
No. It's really hard to absorb all of that in 3.5 hours?
It is, yes.
But it's great. We use your videos
Okay.
to help the people study for the exam also.
Okay.
But they have to go through our 15-hour course
Yes.
first. But I'm just going to leave some flyers
Yeah,
over.
wherever you like. Yep.
Okay.
Okay.
Maybe I'll leave them.
Okay.
Great. Sorry to interrupt.
She did a great job with that Moore project. And like I said, that's more going to teach you things. Here we're just reviewing things. Hopefully you'll learn something too. But this is a little more about reviewing and teaching.
Right, and not only that, if you pass the exam through the Moore project, unfortunately we can't grandfather it to other groups. But if you pass through the Moore project, then we give you a radio, and it's a really nice day too.
You don't get a radio.
FT65R. Yeah.
Right. You don't get a radio from me, so that's
No,
pretty
we can't
good.
give you a radio. So, well, I'm not telling you to flunk the exam. I'll get down with that. It's a really nice day. But we also have other tutorials, get on the air stuff, and we deal with software defined. So I'll leave these flyers here, and when your meetings come, I'll try to swing by at the end because I don't think there's anybody here from the Moore project. But if any of my Moore project people come in who didn't pass their exam, and they test, then we'll pay their.
Okay, just talk with John and those guys when they come.
Yeah, just talk.
Okay, very good.
Oh, it's taking one right away.
All right.
It's about time you got license. All right, so I'm gonna leave some business cards and then I'll let you get back to the very important E equals I off. Everyone loves it. All right, here's some.
Oh, thank you. All right.
See ya.
All right, you too.
All right, good luck with everybody. Good luck with the exam.
Thank you for stopping by. See you a little later.
Oh, you're welcome, yeah, I'll be fine.
All right. Sounds good. All right, take care. Okay, all right. Okay, so again, there's our first two equations, E equals I times R, current is equal to, and you kind of see the relationship. I got this ratio, voltage over resistance. If the voltage goes up, that number's equal to current. If the resistance goes up, that number goes down. Like, it all kind of makes sense. And of course, resistance is constant. So here's a couple of examples, right? These are examples that are taken right from exam questions. I've got 90 volts, got no voltage applied across a resistor, and I've got 3 amps of current flowing. What's the resistance side? Well, resistance is equal to voltage over current. 12 volts applied to a circuit with 8 ohms. Okay, so now what am I looking for? I'm looking for current. So I cover up current that I've looked with this equation. Well, now, I will tell you that usually the way the multiple choice tests are written, the other answers, the wrong ones, will be if you did the math wrong. Okay, if you added, subtracted, or multiplied, it should have divided that way. So, but it's helpful to kind of put this on your scratch paper. You know, the equations. Okay. And of course, the last one, 2 amps flowing through a 100 ohm resistor, and it's just the product. Okay. All right, let's talk about what we call series and parallel circuits. We'll start connecting elements up for the electronic components. Series circuits are when devices are connected end to end. Like one end of like this is a symbol for a battery. Okay, connected up to this symbol for a resistor. We're going to talk about these later on. So I've got 2 resistors, and you can see everything is connected to end to end. It's just one loop. That's called a series circuit. Series with. So, and then parallel circuits are where you've got components that are kind of connected next to each other. It's like railroad ties, railroad track. We take a look at these. In series circuits, there's only one path for the current to flow. That's how it flows through everything. So the current flowing through that thing is going to be the same through all the components. Right? There's got nowhere else to go. It's like one pipe all the way through all the devices. And so, and current is essentially unchanged at any of the junction components. The current is going to be continuous and has to. So the voltage across each of these components, these 2 components, is going to be different. It's going to depend on the type of component and current that's flowing. Right? We can do I times R to figure out the voltage across that guy, and I times R to figure out the voltage across that guy. And it turns out that the sum of that voltage plus this one is going to equal that. Sum all the voltage going around the loop. It's going to equal 0. Okay, so this is a 9-volt battery here. Okay. The sum of the voltages across R1 and R2 would have to equal 9 volts. What would be 4 would be 5 of everything. So again, the sum of the voltages across the components in a series circuit is going to be 6. Now, parallel circuits, you can see right away that, well, that same voltage is applied to both of these things. So each component is connected to the voltage source effectively independently. They both are going to, so each of these 2 resistors is going to see that full battery. But now, so the voltage is the same across each one. But now the current will divide. Okay, current that flows out of the battery, some of the current will go down this leg and some of it will go down that. So again, how much current each of those is depending on, well, by resistance. So the current divides at the junction depending on the values. At any junction point, the total current is going to have to be that current going in is that the current that's leaving. It's like or at the other end, 2 currents summing up with this. So again, the sum of the currents in each component equals the total current. So that's basic. That's basic Ohm's law. That's really all you need to know for the exam. And it's a fundamental concept in electronics. So what about power? We didn't talk about power. Power is the rate at which electrical energy is used. Okay, so if you think about it, it's actually measured in watts. Everybody knows watts, right? A 50-watt light bulb, like a 100-watt light bulb, like whatever it might be. But how much power that device or that, in this case, that light bulb is using. The symbol is P, thankfully, P for power, that's good. And then W is the unit symbol, like if you pick up a 75-watt light bulb, it says 75 W right on. It's often not measured directly, but it's calculated. So it's calculated typically by, as we'll see in a moment, volt current. Okay. So here's a similar chart to the one we just did for Ohm's law. This one relates to power. Okay. So power is equal to voltage times current. Right. And again, we do the same trick. If I know power and I know current, I can calculate this guy by doing power divided by current. And so you get those same three equations the same way using this. We can call this a pie chart. And it doesn't matter if you reverse the I and the E if you want to do pi that way. So you get those same three equations the same way that we just talked about with Ohm's law. About the one you want to calculate, and knowing the other term. A couple of examples. So how much power, so we want to know power, so we're going to cover this guy up. How much power is being drawn by a circuit that draws 10 amps from a 13.8 volt source? So I'm just going to multiply those together. So I've got a 12 volt voltage and current of 2.5 amps. What's the power? Again, same equation. Multiply those together. Third, I've got another 12 volt circuit that's supplying 120 watts of power. Current is actually that source. In this case, we're trying to figure out current, right? So we use this equation here, right? Cover up current, we have power divided by voltage. Okay. Makes sense. So now you know how to calculate Ohm's law and power. And just good basic electronics. A couple of things, some more math for electronics. Unfortunately, there is still some. Oftentimes we use a lot of prefixes, right? Prefixes are used to denote very large or very small quantities. And we use them all the time without even thinking about it, right? I think somebody talks about kilometers an hour. That's kilometers an hour, right? 1,000 meters an hour. So it's one of the prefixes. So one that's very common in electronics is a small letter M. Small letter M stands for milli, which is the same thing as dividing a quantity by 1,000. So it's like 1,000th of an amp, right? It's 1 million. So that's a very, very common one. And small m, differentiating that from a capital M. So micro is even smaller than a milli. It's another 1,000 times smaller. So it's 1 millionth of something. Okay. And we use the Greek symbol mu for micro. So a 1 millionth of a volt would be 300 volts. And then pico is even smaller yet, another 1,000 times smaller. So it's a millionth of, it's a millionth of a millionth. A couple more orders of magnitude. So pico is a millionth of a millionth, very, very small value. So we talk about micro volts here, for example. We divide that by a million again, and that would. So these are commonly used prefixes when you're talking about very small ones. Make sure not to write a lot of pops. So we also have prefixes that for large values. We talked about kilo already. Kilo is a multiplier of 1,000. So saying something, they've got a voltage source of 1,000 volts. It's the same thing as saying 1 kilovolt. Mega, that's the capital M. As opposed to small m. That's a million times. And then giga is a billion times. Okay. Everybody got Wi-Fi in their house. I don't know if that's 2.4 gigahertz, 2.4 billion cycles per second. Okay. That's the RF that's coming out here with better. So again, prefixes are often used on many different types of electrical quantities. It could be component values, it could be resistance or voltage or power or whatever. And sometimes you might have to convert between one or the other. Okay, so a couple of examples. Right? 1,500 milliamperes, right? Well, I've got that many milliamperes, I don't really need to use million anymore. So see, that's 1.5. 1,000 volts, because our example was our 1 kilovolt example. 1 millionth of a volt, that's our 1 microvolt example. So you get rid of these large numbers. 3,000 milliamps is just 3 amps. And then here's a little bonus one. So 3,500 kilohertz, right? 3,500,000 hertz is the same thing as 3.5. Just moving this decimal point. So again, a couple of these might show up in the exam. And then this is a good example for the Wi-Fi. 2,425 megahertz is also 2.425 megahertz. But it's not going to be send band or Wi-Fi. And your microwave Wi-Fi that's there. All right. The other thing that we'll talk about with math, and again, oftentimes to deal with very large or small quantities, is this concept of decibels. It's typically used when we're dealing with ratios. So if somebody just says something about decibels, dB, they're not really talking about an absolute value, an absolute voltage or an absolute current, an absolute watts. We're typically talking about a ratio. Okay. What I mean by that, if if something is twice as big, twice or half as big, 10 times larger, 10 times smaller, that's a ratio, not an absolute. It's only when you reference it to something else that it becomes an absolute. Like I can say, I'm twice as smart as the rock. But we'll tell you, the rock isn't very smart, so I'm not very smart. So, but those are ratios. And then when we cascade these ratios, like if you had something to say, okay, this thing is twice as big as this, and that one is 10 times bigger than that, I have to multiply those together to figure out how big it is total. Right? With decibels, we do addition and subtraction instead of multiplication and addition. So that's one of these functions. So cascading decimals add or subtract as opposed to cascading ratio. So a positive value in dB represents an increase of some value. So hey, this signal is 3 dB stronger than that one. Higher power. But if I say that this signal is negative 3 dB compared to that, it's lower. So some ratios to remember. We're not going to go through the math how to compute decibels. There's just a couple that you want to remember because of a question or two. 3 dB is equivalent to a factor of 2x, like 2-to-1 ratio. Twice as big, half as big. Twice as big is plus 3 dB, half as big, or half the size would be minus. 6 dB is a factor of 4. For the HamCram? Sure, yes. So 6 dB is a factor of 4, like a 4-to-1 change. Okay, so a change, say, from 12 watts to 3 watts in the transmit power gives you a 6 dB decrease or a minus 6 dB change. Okay, ratio of 4 to 1. 10 dB is a factor of 10. That one's easier. Okay, so 3 and 6 dB, 2 and 4. So again, it's a 10 dB factor. So if I have a transmitter is putting out 20 watts, and I put it through an amplifier that makes it 200 watts. That's a 10 dB. And combination of the decibels add or subtract. So a 13 dB change is the same thing as a factor of 4. Right? So that's 10 plus 3, the same thing as 10, this 10 times 2. So we see how we go from multiplying things to just 10. We often do this because we might say, and 10 has got this much gain, the propagation from one place to another has this much loss, and the ball has in dB, so it's adding over that plus rather than trying to multiply all that stuff out. But these are the ratios that one of these might appear. So any questions so far? That's kind of your basic electronic principles. Ohm's law, voltage, current, resistance, power, watts, waves, those. Some of the prefixes you'll see, and decibel ratio. So there'll be a small handful of questions on electrical property and principles. That's it.
We refer to cascading ratios in terms of cascading.
Yeah. So So cascading means like, let's say I have, transmitter putting out 1 watt of power. And I have an amplifier that's gonna increase that power. Okay, then I go into an antenna that's got a gain of 3. Right, the total of that's 13. So those things are cascading values. So, okay, this thing is half as big, then I go through something else and it cuts it in half again. Those are cascading. Okay. Sorry. Okay. Yeah, logarithmic, we add them, and then like I said, we just talk about the ratio of multiplier. Right? But it is based on logarithms. Right, so otherwise you're going to go to the next. So, all right, so the next thing we're going to talk about here is a little bit more on electronic principles and components. You see a bunch of symbols here. We're going to talk a bit more about the symbols and what some of the basic components are. So the first thing is resistors. It's kind of right in the name. So this is the symbol for a resistor. In the US, we typically use this little squiggly line. Oftentimes in the rest of the world, they use those resistor schematic diagram. Okay, resistors oppose the flow of current. So they basically are limiting that current flow of the circuit. There are variable resistors. These are things that have got knobs on them to change things like the volume controls and things like that. And the symbol for those looks like a resistor, but with this little tap off there that can be moved up or down. So very, very illustrative of what it's doing. Okay, so I've got this resistive element that I'm just going to tap off at some point with varying resistance across. So they're called potentiometers, oftentimes used as a volume control. And again, resistor value is expressed as we talked about earlier. Oops. There's that. Very, very basic component. There are some resistors that are built for some. Capacitors. Capacitors, there's a number of different symbols for them, depending on the schematic you're looking at. These are what some of them look like. Lots and lots of different types. Basically, it's just 2 conductors separated by an insulator. Well, what stacks the circuit? But the reality is that when you start getting voltage that varies, you're charging and discharging the plates, charging and discharging plates on that. So there is some momentary current that flows to charge or discharge. So you did get some current flow when things are moving around. It's just DC flows like a circuit. So if I change the voltage on this capacitor from 1 volt to 2 volts, some current has to flow initially to pile charge up on it, and then it's charged up with current. So 2 conductors separated by an insulator, or what's called a dielectric. That's the capacity. And one of the things that there may be a question on is that it stores energy into an electric. As soon as I charge up the capacitor at some voltage, it's got some energy, right? That energy is stored in what's called electric field that exists between those 2 plates. Okay, discharge. Have you ever had an old flash camera that you go to pick the flash and you go, it's charging up a capacitor at a high voltage. Then when you take the picture, you get the flash. That charge discharges to a flash tube. Okay. So capacitance is the ability to store energy or electric. So it really is the property of capacitors. Okay. Again, metallic letters, like the words that are in electrical numbers. So there's different types. There are some that are polarized capacitors that may have a plus symbol on one side of them, meaning they can only be used with voltage one polarity, not the other. And then variable capacitors, anytime you see an arrow going through something like that, it means that the value of that can change. Okay. So again, the unit of measure of capacitor is a farad. So if you don't heard that. Okay. That's the name of it. And oftentimes, capacitors like these types are very, very small numbers of farads, meaning like million of farad, billion of farad. So often we'll see values of 1 microfarad. Yeah. So electrolytic, let me back up, sorry. So electrolytic capacitor is one of the polarized types of capacitors. It's that instead of having just an insulator between the two plates, it's actually a chemical, a dielectric chemical that if you apply voltage one way, creates an insulated layer. If you apply it the other way, it would actually conduct in a destructive way. So you don't do that. Okay. All right. So, but the dielectric layer is essentially formed by the presence of. So, where capacitors store energy in an electric field, there are these things called inductors that stores energy in a magnetic field. Now, how many guys when you're kids have run experiments in your science class where you took a battery with not the wire around the nail, connected to the battery, and put it into an electromagnet, throw the battery, and get the clips drop off of the nail? Right? That's because by wrapping that coil of wire around the nail, you concentrate the magnetic energy from the current into that nail and turn it into a magnet. So inductors effectively store energy in a magnetic field. And they literally, the symbol of them looks like a coil of wire. Oftentimes that's what they are. So from a DC standpoint, it's just a wire, right? So it has no resistance or function. What happens is when you start, again, changing the voltage plus, that electric field expands, contracts. The more current you have, the less current you have, expands and contracts. That movement of the electric field tends to oppose the change in current. So it creates current that will change as a function of the frequency. So oftentimes, again, it look like pretty simple things, like it's just a coil of wire. Right? It does when you have signals that we. Okay. A couple of examples of inductors. If there's typically if there's lines next to it, it means there's some kind of core material that we're wrapped around. Okay. And you got your variable inductors, things like that. Again, oftentimes just a coil of wire. Your electromagnetic experiment rates. Okay. Again, the ability to store energy in a magnetic field is called inductance. Okay. It's like capacitors, inductance. And again, we've got another unusual name for the unit of measure is called the Henry. Okay. So we got to remember Farads for capacitors, Henry's for inductors. It's the actual unit of measure. Okay. Is that good? Those stories of all of them. All right, switches. Really, so it's always fun. So that's one of the sticks. Right, yes, exactly. It's like, why did they do that? Doesn't make any sense. Oh, that's the guy who did it. Okay, warm up the boiler wasn't. So switches are actually pretty easy. So obviously used to connect or disconnect electrical circuits. Those are switches. The symbols are pretty descriptive in terms of what they do. So there's some generic switch symbols. This switch consists of two parts. There's a movable part. You're actually flipping the switch. You're actually moving the conductor. They're making contact with something or not. That movable part is called the pole. Okay. And then the places it can go is called the throw. Okay. So in the case of a simple switch, you turn something like a single light switch on or off, a flashlight on and off, would be a single pole, single throw, SPS. A single pole that I close the circuit to light up the light, open, close, turn off the light. And then there are single pole double throw switches, off like three-way switches are in your house, or actually single pole double throw. They can turn off on either side. Okay. So again, so the pole is the moving part, the throw is the places it can go. And then it's a single SPST, a single pole, single throw, double pole, double throw. Similar to the double pole. The dash line between poles indicates that they're linked together. Okay. Fuses are switches that open themselves up once. Give up their life to kind of save yours. So they basically protect circuits from overload in the section of current. Use the typical fuses that you find in your car. Well, now they have really tiny little. Everybody had to replace one of those really tiny fuses in your car. I had to replace one for my truck the other day. And it was like half the size of these, right? pulled it out and tested it. It wasn't bad. Well, it was nothing to it out. I went to put it in. I dropped it right inside the fender well. And the other box get it out when you can. So, but again, they protect circuits from overload. Basically, what happens when the current reaches some threshold value, okay, they just say, "Oh, that's too much," and they just wire it, and it's basically melts. And it's a circuit. So they're rated in amps typically. Okay, how much current they can pass before they will flow. Okay. And the symbol for them is just a little weakly wire. Okay, batteries. We all know what batteries are. The symbol for a battery is usually a set of long and short line. It looks a little bit like a capacitor, except that typically one bar is one long. A single cell, like a 1.5 volt battery, is a single cell would oftentimes just be represented by a single pair of these. When you've got something like a 9-volt battery or a higher voltage battery, it's actually multiple cells in series and the voltage adds up. And that's why you see that it's typically represented by 2 or more of those. We generally don't represent the total number of cells in a battery like that. And we kind of use the terms battery and cell interchangeably when we really shouldn't. Right, the 1.5 volt batteries are typically a single cell, but like a 9-volt battery, a 12-volt battery is actually a multiple cells. So we call them all batteries. Right? Again, primary batteries are not rechargeable. These are your old carbon, zinc, or alcohol batteries. You can't recharge. Use them once, they're done. Okay, secondary batteries are ones that are rechargeable. Like lithium hydride, LifePro batteries, or lithium-ion batteries. These are all forms of secondary batteries. And the different types will have different voltages, right? Like an alkaline battery, a single cell is typically 1.5 volts. A NiCad battery, a NiCad cell is typically 1.2 volts. The lithium-ion cell is typically about 1.6 or so. Other lithium cells are like 3 volt, depending on how they're built. But different chemistries will have different cell voltages, and then sometimes they combine to create. Okay. Now we start getting into semiconductors. So we talked about your really basic passive components, resistors, inductors, capacitors. We talked about switches, fuses. Semiconductors are things that actually change the properties depending on how you're driving. So there's a number of different symbols for diodes. Typically, it's either an open or a closed triangle with a bar. They only allow current to flow in one direction. What they are, it's how the one-way check. And the current flow, the conventional current flow, is in this direction, the direction of the diode. So it's either current going this way, so the arrow keeps going. Current going this way, kind of gets. Lots of different types of diodes. And we'll talk about a couple of these. The LEDs, you can the term LED, that's just a light emitting diode. Fast current through it. Emitting diode typically looks like a diode with arrows coming off it when something's coming out of it. So they only allow current in one direction, and we call that forward bias. The terminals of a diode are called the anode and the cathode. The anode is the positive, the cathode is the negative. Okay. So, and then I think of the negative as the bar. So the cathode has got, so typically on an actual component, the cathode will be typically indicated by a stripe. Okay. So a black stripe here, a black stripe there. That component is the cathode. Another term for a diode is called a rectifier. Okay. It rectifies alternating current or direct current. And the forward voltage drop, that when I pass current through this diode, there's going to be a voltage drop across it. Okay, it's generally somewhat fixed, unlike a resistor, very linearly with current. The voltage drop across the diode and the forward bias is highly constant. For our intents and purposes here, it is constant. So you lose a little bit of voltage going through it, but the current is not flow pretty freely. So the forward voltage drop in some diode types is lower than others. So in cases where you don't want to lose too much voltage across that diode, the lower voltage drop, there are some turn types that have got lower voltage. So light emitting diodes, we talked about it a bit already. It's just a diode that creates light when it's forward biased and current flows through it. Okay. Typical components used to look like this. Now most of the stuff is all surface mount, packaged a little bit different. Old LED display, you don't see anymore, but so again, commonly used as a visual indicator. All right. So again, italicized text might be a question. So the next most common semiconductor is a transistor. Lots of different types of transistors. We're going to break it down into just two different classes. Okay. Transistor in general, though, is a component by which current flowing through it is controlled by third terminal. So the three-terminal device. See all these transistors have got three terminals on them. So the current flowing through the device is controlled by either another current or voltage on a third terminal. It's not like an electronic. Electronically controlled resistor in some way. Not entirely accurate. That's a good. So it's often used as a switch or an amplifier. Okay, so to turn something on or off, or a transistor on hard or not, kind of form of an electronic switch as opposed to a mechanical switch. But it can also be set up to use as an amplifier. You've got a small voltage or current, or a larger voltage. Gain is a term that we use, which is the way of measuring a circuit's ability to amplify. So how much gain can I get out of a transition? So how you set it up for circuit. So again, it's really good. So it's really the ratio of the input output voltage set up. Okay. And you could also have something called power. It's very low power signal. So some transistor types. We're just going to talk about two. So one is bipolar transistors. And these are the symbols for them. There's actually two different types of them. There's a PNP and an NPN. It really comes down to the types of semiconductor. In the very broad class of semiconductor materials, we have what are called N-type materials have a little bit excess electrons that flow around. And P-types really have a void of electrons, actually have what we call holes, places where electrons go. It's positive, negative, electrons are negatively charged, that's again, it comes the absence of a positive charge. When I combine a diode, for example, just a P and N type put together. Okay. A transistor is we add a third terminal with another one of the multiple types. Again. So in the case of these, the NPN or PNP just kind of refers to that structure. In the case of like an NPN transistor, the current that flows from the collector to emitter is a function of the current that flows from base to more current into the base, more a larger current can flow. Terminals for a bipolar transistor are base, collector, emitter. Again, something about electronic. So that's all there'll be. I might talk about the layers, type, or the terminals of the bipolar transistor. Some other transistor types. The other broad class we'll talk about is something called field effect transistors. FET for short. There's lots of different symbols for them. Okay, we'll go into all the differences there. The current through the FET is controlled by the voltage on the gate. Right, the bipolar transistor is current in the base. On a FET, there's voltage on the gate. The current flow through the other terminals. Okay, the three terminals here are the gate, drain, source. Okay, the gate is, I think of it as gatekeeper. Right, voltage on that determines the current that will flow from the drain to the source. Okay. Again, fortunately, this thing you have to memorize it. So we talked a bunch about electric schematic symbols already. A lot of show you what those symbols were. Again, schematic symbols are just standardized representation components when you actually go look up the circuits. We talked about these guys already: diodes, capacitors, inductors, resistors. A schematic diagram depicts the interconnection between those, how they're connected up with the circuit. So here's an example of a schematic diagram. Already see some of these things. I can see bipolar transistors. I see a couple of resistors. I see a variable capacitor over here, a diode over there. See how they're all connected up. All good? Oh yeah, we're good. There's lots of different schematic symbols. Again, some symbols will have little variations of what they may look like depending on country of origin and different styles of drawing a similar thing. You know, like a drop in like a little coil, sometimes I look like a bunch of rough things. Just variations on the same thing. So they're standardized, but they're a little bit of fuzziness. So here's an example schematic diagram. Again, we can identify all the components here. There's a resistor right here. There's a battery right here. Another resistor, bipolar transistor. This one here, just a circle with an A in it, just to be the notion that how you know that can be. So there's only, I think on the exam, there's maybe a total of 3 different schematics. 1 of the 3 that you see. It's often about just identifying what the component is that. So here's one example of one of them might be on the exam. And this is a very, very simple circuit here. You take a look at this. I've got a resistor in series with the base of this bipolar transistor. So that's going to limit the current going into the base. Right, over resistors with current. And if I put current into the base, that transistor turns on. So current flows from flow from the collector to the emitter. So that voltage from this battery flows through that light. The light on. Okay. So the resistor is used to limit the input current. The transistor is used to control the flow of current through the lamp, which is right. 3 is the lamp, and 4 is the battery to supply current to this light. So there's 4 questions, one of which might show up on the exam, and those are basically what the answers to that question. Oh, and then this symbol down here is chassis graph. Electrical box, or the chassis of whatever device it is. Another example, this is a simple AC to DC power supply. So I've got my symbols by line voltage coming out of my wall. There's another symbol for a fuse, type of symbol for a fuse, a switch, turn it on or off. Going into this guy, which is a transformer. 2 couple of inductors together, this little transformer, and we'll basically take the higher, like 120 volts that I've got here, and either step it up or down the other side. Okay. Goes through a diode. It's going to rectifier. What's going to do? It's going to take that AC signal, turn it into only let current go one way, and turn it into DC. And it will dump some of that current onto this capacitor, charging it up, okay, creating essentially a DC voltage power supply. And then there's a resistor limiting current through an LED, depending on the power supply is on. There's another resistor in series with the output. There's a zener diode here. Again, this one is just identifying. Okay, the question might ask, where's the fuse? Oh, it's number 2. Okay, what kind of a switch is number 3? Same pole, same foot, right? The transformer, and that's used to take, this case, taking 120 volts AC to a lower AC. Rectifier diode, right, turning the AC to DC. Capacitor is helping to remove that pulsating DC and making it smoothing it out by storing that charge up capacitor. So that's going to do that variation of the LED just to show that it's on. Then there's a variable resistor here. I'm sorry. Number 1 in that case, that's actually the symbol for the wall up. Okay. So it looks like it's a okay. It does look like a capacitor, but the back would go so far. Okay. One more. Here's a very simple antenna tuner. What do I see here? What is that? Okay. Variable inductor. That's one you haven't seen before. That's a simple for it. So variable capacitors together with the variable inductor are used as a tune. So remember I always said inductors and capacitors don't want to do anything. It's they're leaving them out. They can combine them together. They can really do some very useful things. circuits. So capacitors and inductors connected together are often used as filters or tuned for resonance circuits. And then number 4 is so resonant tuned circuits, we'll talk a bit about that. This again, when capacitors and inductors are used together, either in parallel or in series, they can produce some. And we introduced this term called impedance. Impedance is kind of another word for resistance, except that when we talking about AC circuits, we talk about impedance instead of resistance. The impedance can vary as a function of frequency. Right? You think about with the capacitor, the DC cross and no current flow, start fell. But if I start moving that voltage, then I start getting current flows. I'm charging the capacitor faster that I move. Faster I'm moving current, more current. So the effect of resistance or impedance of the capacitor goes down as the frequency goes up. Right? Inductor the other way around. So because these two components operate in opposite ways with changes in frequency, combining them together can do things like create filters that will have a response at one frequency and reject others, or filters that might reject a certain frequency and pass others. Yeah. Did the 3 lines, right? Good question. Whenever you see lines adjacent to an inductor, it means that there's some kind of a core material, either iron or like core or something to take the air around for it. So when you combine resistors and capacitors together, they have what's called a resonant. Resonant frequency is when the reactance of the impedance of each. Remember how one is going down with frequency, one's going up. At some point, they equal each other. That's called a resonance. Okay. So a parallel circuit, a parallel resonance circuit has a very high impedance at resonance. So that's this guy right here. So at frequency where capacitor and inductor represent effectively the same resistance or reactance, this thing will almost look like the circuits on. Right, so the impedance, if you will, peaks at the resonant frequency and drops on each side. And then low frequencies all the way down to DC, eventually that was a short circuit. See, but now as the frequency goes up, this guy starts looking like short. That guy. But by cross, when you have them in series, the opposite. Right? You have the lowest impedance. Yeah, so yeah, depending on how you build these things, I mean, this is kind of a crude representation. It's not really that sharp. Great.
But that's what you're saying about the end, right? Kind of so sharp that.
Right. Okay. So think about this axis of resistance. So that's probably as complex as we're going to get with components. Okay. Any questions on that? Good. A couple of other components. You heard the term relay. A relay is nothing more than a switch that's controlled by an electromagnet. So basically, apply current to this electromagnet, it pulls down on and closes the switch. You got them all over your car. You turn your headlights on, or you turn your blinkers on. You're a relay. Right, the headlights on. So it's helpful to allow a relatively low power thing to switch some high power. So electronically controlled switch, electrically. A meter, obviously, how to measure something. So some kind of a shielded wire. The shielded wire is used to help prevent coupling of the signal on that wire to the typically the wire might have, a metal shield or even a braid, metal braid around it, surrounded it, kind of isolates that coupling of something else. A regulator is a type of circuit that, in our case, in the case of the exam here, talk about it, is something that will control the output voltage. So that even if the load that is applying draws a lot of current or low current, tries to keep that voltage. An integrated circuit with inside your electronics and all the little black rectangles. Like those are all integrated circuits. basically combine many, many parts, typically a lot of transistors, into one small package. So they combine many parts to perform other analog and digital functions. They have prior to the process. Okay. Done with electrical principles. Okay. See, I've kind of been yapping along here for a little over an hour. Ready to need a break, or are we good to go? Keep going.
That's not a problem. Electric stuff.
Okay, all right. All right, so let's go to another section. If we need a break, we'll take a break. So it's about 20 minutes. Cool. Okay, so radio wave properties. We talked about a couple of, we talked about what frequency. We'll talk about the rest of the stuff. Okay, so radio waves are also known as electromagnetic waves. Okay, because they contain, you can't see them, but if you were able to visualize them and see them in space, they actually consist of two components: an electric field component or a magnetic field. And if you were able to visualize them, these are variations of field in space and the way they're moving. Well, actually, for many degrees from each other. This way, this way, this way, this way. Out of polarization. So electromagnetic field components that are these right angles to each other. Okay. And radio waves travel through space at basically the speed of light. Okay. And these are what carry signals from receiving. The only thing to remember here is that radio waves are carrying signals. They've got both these field types. Let's call them. Okay. So let's talk about frequency and wavelength. So the frequency we talked about earlier is the number of times that signal goes through a complete cycle per second. Okay. Oftentimes we're talking about RF, we're talking about megahertz, okay, gigahertz, things like that. Lots of cycles per second. Frequency again measured in hertz. The wavelength is how far that thing travels through one cycle. Right? So I'm creating a wave here. The antenna's got radiating that, and it's shooting out with the speed of light. Okay, but by the time I complete one cycle, where's the beginning of that? Right, that's called a wavelength. So the way to visualize that is looking at it. Right. So if you imagine the speed is constant, but the faster I wiggle, right, the shorter the wavelength. Right, if I'm wiggling really slow, by the time I get back to the beginning, that other one speed of light play at me. But if I'm moving really fast, by the time I go back to the beginning again, maybe I got this one. Right? So wavelength and frequency are just inverse to each other. So a couple of ways to look, another way to kind of draw that. So again, travel at the speed of light in free space, and that's about 300 million meters per second. 6,000 miles per second. Good. So again, regardless of frequency, all these radio waves travel at the same speed. Okay. It's like the speed sound of talking a high pitch or a low pitch voice, all that sound is you can hear at the same time. Radio waves are the same way. The speed of radio wave propagation through space. Again, wavelength gets shorter as the frequency increases. So this is why, if you ever look at drive up the turnpike and see the big antenna towers for the AM radio stations. AM radio is very low frequency. The antennas are really big because they're not proportional to the wavelength. Whereas if you look at the back of your router in your house, the antenna's not that big on the back of your router. That's 2.4 gigahertz. Wavelength is full option. So again, the simple equation to calculate the wavelength is if you take the frequency in megahertz and take 300 and divide it by the frequency of megahertz, that gives you the frequency in meters. Excuse me, the wavelength in meters. Okay. So 150 megahertz signal is about 2 meter long. So let's talk about radio frequency bands. Kind of break them up into bands because the propagation and things like that and use cases for different frequencies are kind of grouped together as we kind of group bands of frequencies. So the approximate wavelength of radio waves is used to identify, especially in amateur radio. And I say approximate because if you do that math, we're going to divide it by the frequency layer. Well, not exactly, but it's close enough. So an example, in amateur radio, one of the bands that we use is we call the 2-meter radio. Okay? 2 meters would strictly be 150 megahertz. But our amateur radio 2-meter frequency band is 144. So 300 divided by 144 is exactly 2. So we call that the 2 meter. Okay. Same thing, we've got a band that we call 40 meter. Spans from 7 megahertz to 7.3 megahertz. Again, if you do the math, 300 divided by 7 isn't exactly 40, but it's close enough. So when I say it's approximate, it's because not on the system. But now we also break up the RF spectrum, if you will, in broad classes from low frequency to high frequency, and break it up into various groups. Okay. So RF is radio frequency of all types. RF stands for a full range of frequencies are divided into these sub-ranges for convenience. Okay. The most common for amateur radio are the HF band, which is 3 to 30 megahertz. Okay. VHF, which is 30 to 300 megahertz. And then UHF, which is 300 megahertz to about 3 gigahertz. So these strict terms, HF, VHF, and UHF, refer to those boundaries, 330, 300. Yes, so you notice it's 3 kilohertz, so very low frequency, 3 kilohertz, which is audio. That, right? 30 kilohertz, LF, low frequency, very low frequency, medium frequency, MF, or AM broadcast there. So 40 kilohertz to 20 megahertz. So that all lives in MF, or medium frequency. Our amateur radio bands start a little bit below 3. Okay, so that's why it's kind of shaped there. But the HF band itself is 3 megahertz. So a lot of shortwave radio stations and a lot of amateur radio operation. VHF television, FM broadcast, that's all VHF. Police fire radios, things like that, they're all typically VHF, VHF. A lot of megahertz stretch. That's just getting low VHF. So high frequency, very high frequency, ultra high frequency, super high frequency, as SHF, and extremely high frequency. But again, these are the 3 that are the most. So let's talk about the properties of these different bands. So different bands have different propagation properties, therefore different use cases. VHF and UHF, okay, again, that's 30 to 300, 300 to 3 gig. Typically what are called line of sight communications, meaning that my radio and your radio have, from an RF standpoint, have to be able to see each other. Okay? They don't have to visually see each other, but they can't be beyond the horizon very much. Like the signals that can't be blocked by something that would block the RF energy. Okay, so the signals are generally not reflected off the ionosphere, bouncing off something in the sky and coming back. It does happen, but it's generally not a common use case, and they're rarely heard outside of a local area, that line of sight area. So the radio horizon is where radio signals are blocked by the curvature of the Earth. Okay, and the atmosphere does a little bit of refraction on the RF signal, so the signals actually bend around the Earth a little bit. So the RF horizon is a little bit further than the visual horizon when you're looking at it. If you're standing on the beach, you can typically see the horizon line is about 6 feet tall. It's about 7 miles out. Okay. The RF horizon is a little bit further than that. It's the atmosphere tends to refract about a lot. So the radio horizon is slightly greater than in this kind of unrestricted, non-mountainous type of scenario. You can get this thing with VHF and UHF in particular called multipath. Okay, multipath is when I've got a signal that may come from this aircraft down, straight down to a receiver, but then also be reflected off of something. Okay, in this case here, from this transmitter to the receiver, there's my direct path. I might bounce off of a building and come there. I might bounce off of a mountain, bounce off of something else. And have these other paths all that all sum up at your receiver. And how many of you ever like pull up at a traffic light, all of a sudden the FM radio station you listen to just went out, and you pull up about another 2 feet and back? That's cool. Because what happened was where you happened to stop at first, the direct path and then a multipath signal came in slightly out of phase, and they canceled each other out. It wasn't like the signal was blocked there, but probably it was the signal summing up in a long way to cancel itself out. And if you move, the phase change a little bit more, and it's came back. Again, if you're affected by multipath, move a couple of feet. Right? It might say, yeah, I should probably hear that guy. Why am I not? Oh, okay, I'm okay with it. Right. So multipath can affect digital signal error rates. So got a lot of average radio types that will send digital signals back and forth, and the performance of that is typically called error rate. They have the error that they're receiving for everything that they get. So again, there's a question. Okay. So you can get signal reflections. Again, the higher you go in frequency, generally this happens more and more. So if you can't reach a VHF or UHF station, try directing, if you have a directional antenna, try directing it or something like that might reflect the thing back in. Think of a ping pong ball bouncing off of something. So in this case here, a signal from this satellite from this car might be blocked by this building, but it might reflect off of that. Oftentimes it just happens, you don't think about it, but if you're dealing with some other directional antenna, you might be able to catch. Again, multiple and change your reflections due to being a moving vehicle. In a scenario where you pull up and it's going away and move a little bit, if you consider moving through that, sometimes you might feel a signal flutter. What we call picket fencing. When you were a kid, you used to go through a van in the hallway. Shop, the same kind of thing. But because you're moving through these areas, the signal is adding to itself, tracking itself. So we call that picket fencing. So a little bit more on VHF and UHF. UHF is generally better at penetrating building structure than VHF is. This is why the police, fire in the cities, things like that, will use UHF radios. We're working with them, especially. The higher frequency, the UHF is actually better than VHF through the structures. Typically, because a lot of times the structure will have things like rebar and stuff like that, and that there's some spacing. So those are conductors, but there's enough spacing to facilitate get through. We've got a longer wavelength. That's a tough time to get to structures.
The lower frequencies generally.
Very low frequencies like HF, you get through them as well. But with HF, the problem is the antenna, right? So it's not really good for handheld communications. It's going to have an efficient antenna at 7 megahertz. That's why we have something with an efficient antenna for. You can get something called knife edge diffraction off of sharp edges, like sharp edge of a top building or a sharp ridge. Yeah, your refraction things that kind of let you see behind that structure. It's something that happens. And then again, range is generally better in winter because you get less absorption from vegetation and things like that. So let's talk about signal and antenna polarization. And the real simple fact of the matter is if you picture a handheld radio, you have an antenna sticking off the top of it. The polarization is the polarization of the electric field, which is the direction of the antennas. That's vertically polarized. That's horizontal. So I'm holding my radio like this, I'm vertically polarized. I'm holding it like this, I'm horizontal. So again, polarization is important for VHF and UHF. Vertical polarization is often used for something called repeaters. Joe's going to talk about it a little later. So this is something that's used by both amateur radio and land mobile radio services, Inspire, things like that. The handheld radios that they carry don't necessarily talk directly to the handheld radios that all the other people are carrying. They talk to the base station. The base station has got an antenna that's typically up very high in an advantageous location, so that the line of sight is pretty broad, so that when you're talking to radio, the base station is picking you up and retransmitting you out a slightly different frequency, should be heard at a much further distance, and you'd be able to go line of sight. Typically, these types of networks use vertical pole. So you might have better luck using the repeater compared to radio this way instead of this one. Horizontal polarization is typically used for what we call weak signal operation, like kind of pushing the distance limits and things like that. And signals will be much weaker if you don't use the same polarization at one end. But you can imagine if I got a 10 end and match the polarization, great, but if it's not matching the polarization, there isn't a lot of intercept. So again, polarization is the orientation of the electric field. So we said that, you know, for the most part, VHF, UHF is line of sight. You can get these unusual conditions that will allow you to go much further. And one of those is something called sporadic. It refers to the E layer in the atmosphere. Various layers in the atmosphere called E layer, the F layer, things like that, layers of ionization. You get higher and higher. You can get these clouds of high ionization in the atmosphere periodically due to solar conditions, things like that. That can lend itself to reflecting VHF radio signals. So you kind of get this little skip over and go much further distance. Something that we call it sporadic, but it doesn't happen very often. It's not predictable. Oh, it happens there. Again, this can result in strong over-the-horizon signals. In this case, like VHF signals, 10 meters instead of 6 meters. Right? So a little bit more long distance VHF, another rare usual activity. Rain and fog will generally have little effect on 10-meter and 6-meter signals. Microwave signals are much more affected by weather. Other long distance phenomena, something called auroral backscatter, you know, aurora, the lights type of thing. That's like aurora borealis. That can do some weird things with radio signals. Okay. Meteor scatter is another kind of thing that's relatively popular on bands like 6 megahertz band. That's actually where little tiny meteor particles are flying around in space. When they hit the atmosphere, they burn up. When they burn up, they leave a trail of ionized particles that dissipate typically in a few seconds or much less. But while it's there, it will reflect the radio signal. Okay.
Could space junk do the same thing?
It's not crowded together enough to create an efficient radiator, but yeah, it certainly could if it was, you know, a bunch of junk that was close together.
On the atmosphere that reflects back.
Yeah. So and then temperature inversions in the weather can cause something called tropospheric ducting, where kind of the signal gets up in the atmosphere, kind of trapped a little bit, bounces around, and then pops out somewhere else. So you get really long distance contact, and it lasts for 5 minutes, and then it goes away. Nothing you predict, but it's all. So all of our discussion thus far has been on basically VHF and UHF. That's primarily because as technicians, that's where you've got your full privileges. Okay. As you move up in class, you can get privileges on the HF frequency, 3 to 30 megahertz. And these support additional modes of propagation typically around the globe. So HF signals are readily reflected by the ionosphere, and particularly along with the solar cycle. In fact, when we're kind of entering into our starting the next 11-year phase of the solar cycle. So solar images they're very favorable for HF communications. One of the things that I really enjoy doing is operating out in the field at very low powers, like 5 watts of power, plus power. Okay, and talking around the world, 5 watts of power. But it's amazing every time. So, but that's all because of reflection from the atmosphere. The ionosphere is what enables this worldwide propagation, and solar radiation is what sets up these conditions for us. Okay? Typically, the sun goes through this 11-year sunspot cycle, and again, it kind of comes from the next peak of this happens about over 20 years, and it's a good time to get it back. So we get this thing called ionospheric skip. Okay. And so think about, this is a really broad slice through the earth, right? I've got San Francisco over here, I've got Denver right here, I've got Chicago right there, and City up here. Okay. So what's interesting is that if I think I got a transmitting station in San Francisco, I'll have ground wave propagation that will extend out from the miles, and then you get these skip signals, right? So I might have a signal that comes out here, goes up 50, 60, 70 miles up the atmosphere, and it reflects down and being heard in Chicago. But the guy in Denver can't hear you. There's a signal that opens. So it's not uncommon to only hear one side of a conversation on HF, because you're going to be the skip zone for the other one. It's also, let's say, oh, I really can't hear you, you're kind of too close. Does it make sense that it does in this scenario? Okay. So I got to go further away to get into where the energy is going back down to the earth. And you can get multiple reflections sometimes as well. And this is how you make, this is how you make contact with somebody in Italy with 5 watts of power to wire antennas going in a tree in the woods. Now, because this is not a perfect reflector, you do get fading. Okay, kind of random. Sometimes the signals get strong and weak during that same transmission. It's all just because there's clouds of ions kind of get blown around. Like that. Okay. So polarization is not so important, because once you hit this kind of wiggly reflector up there, it's kind of spread on the polarization. So generally, don't have to worry too much about polarization for HF. Okay, it's really just the HF for HF. I guess there's a question that says something like the ionosphere reflection kind of gets you elliptically polarized. That's the term that might be a question. So again, we talked about a couple of layers in the ionosphere. So we get these daily variations of it. So during the daytime, the F layer, which is it actually splits between 2 different essentially elevations above the Earth, 200 to 300 kilometers and 300 to 400 kilometers. Okay. Then you've got the E layer. Remember we talked about sporadic E. That's what happens here. Okay. It's a D layer. And then at night, the F layers collapse into 1 layer, and this is advantageous for when you go down to lower frequency bands, like 40 meters. Generally work better at night because of this. For the higher frequencies, so 20 meters, 15 meters, things like that, those higher frequencies, they generally work better during the day. They use that to So again, our 11-year sunspot cycle affects this, thus it affects propagation. And again, we're right in that natural conflict.
It's in summer camp at night, listen to Wolfman Jack.
Yeah, right. It's because of the change in the ionosphere. But if you're a shortwave, like your certain shortwave stations, during the day, sun at night, there's all the changes in the ionosphere because of the way the sun is struggling. And back in the day, years ago, shortwave stations would ask you, hey, if you heard us, send us a postcard. Tell us what time you heard us, what the programming was. And then oftentimes, that's how they could tell where they're getting to. And they'd respond back and we'll look like a picture postcard oftentimes. And amateur radio carried on that information, exchanging parts like that, or contacts, something like that, a collection of them. So someone sends me a card, I'll send them one back. I don't send them every contact, but if someone asks for one, I send them one. It's got like a picture on it, information on it. It's kind of another tradition carried on. So again, at the peak of the 11-year solar cycle, even the higher frequency bands, the 6 to 10 meter bands, also provide this long distance communication. What's really nice about this is that as technicians, you've got full access to all of the 6 to 10 meters. What's nice about that is because these are higher frequencies, the antennas are more modest, you know, monstrosities. They're get by with a simple vertical antenna or a wire antenna and has a great applications that they now. Let's talk a little bit about antennas and beamlines. So the most common antenna that you'll find, particularly for HF, is what's called an half-wave dipole. Okay. Whereas the approximate length of the antenna from one end to the other is half of a wavelength of the frequency it's operating. And it's fed from your transmitter in a section. Okay. It's horizontally polarized typically, you don't have parallel with the earth, it's horizontally polarized. And radiation is essentially broadside. Think about this as being, the antenna feeding into the center, so it's a half a wavelength. The radiation is like a big donut around this, not so much off the ends. It's a broadside. So a couple more details on the half-wave dipole. But typically, it's about, because of the velocity factor of the wire and passes to the ground, a couple other factors. It's typically about 5% shorter than the free space half-wave. 300 divided by the frequency of meters, about 5% shorter than that. Of course, the equations that they give you, talk about it in English, and it's not necessary. So we can't use that divided by frequencies that give us meters. An example that might be a question is that a 6-meter dipole is about 112 long. And to make it resonant on a higher frequency, you shorten the antenna for higher frequency, shorter wavelength. And the English equation to go to feet is this one. 468. Okay. 468 divided by the frequency megahertz gives you the length of the antenna end to end in feet. Okay. It's another formula right now. Okay. So each leg, if you will, each half of this would be half of that, 2, 3, 4. But you've got to cut 2 wires. Right? It would be 2, 3, 4 divided by that. So vertical antennas is another very common type. There's a very simple vertical antenna for short antenna. Typically, the vertical portion of that is a quarter wavelength. So that's our okay. It's vertically polarized, and again, a 2-meter vertical is about like 100 megahertz. So again, 2, 3, 4 divided by frequency. The length of that vertical radiating column. They're typically some kind of what we call a ground plane. Okay, it may be a magnetic band antenna snapped in your car becomes the ground plane. Or with an antenna you're putting up on a mast, you might have some other little horizontal radios that have form essentially the ground plane. Right? Kind of like the other half of the dipole. Okay, other vertical. So for high frequency antennas or HF antennas, they can be very long or very big, right? Because they're going to be proportional to the wavelength. So low frequencies, the antennas could be, pretty big. One of the antennas that I carry with me in my portable pack is a wire antenna. It's a half wavelength long. 7 megahertz. So I carry an arborist throw line and a throw bag. Like the arborist used to throw a line into a tree and branch out and toss that up in the tree. And then I tie my antenna off of that and make the antenna up into a tree branch and the other end of it. So oftentimes, because these antennas can be very long, there is this concept called looping that can physically shorten the antenna to make it look electrically longer, but it's physically shorter. It's typically done with tuned circuits, oftentimes called looping coils. So sometimes conductors and capacitors may be used in networks. Go electrically make the antenna. The radio thinks the antenna is that big, but physically it's much smaller. So like if you look at the CB antennas on the trucks, they've got these black little foils or boxes on them on the lip cells. That's actually a loop. But CB radios at 27 megahertz. That antenna is 130 feet long, right? So we can't have a 30-foot long antenna on the top of the big radio. Make them shorter. Loading a full-size antenna makes it physically shorter, but it also makes it less efficient. It's not going to work as well full-size. So sometimes it's push. So there are antennae called beam antennas. These are all different forms of beam antennas, and these are, as opposed to what we just kind of talked about, which was somewhat omnidirectional. Beam antennas allow you to concentrate energy in one direction. Okay? Apply, which looks like this set of squares, both of the wire elements separated by some squares. There's an example, a Yagi, which is kind of what similar to this is type of a Yagi, or one periodic, or dish antennas, or all types of directional antennas.
On the Yagi, the crossbars, right, closer space, so different.
Yeah, so this antenna is a little bit unique in that it's designed essentially for multiple frequencies. It's also, you can see the element spacing is different and the element length is different. Okay. So typically the longer elements are at the back of the antenna. So the direction of radiation on this antenna is back. I like the arrow. So here you can see like the old TV antennas, have elements that kind of shaped like an arrow. It was really kind of where the narrowest point was where the concentrated energy. There you go. Yep. Yep. So, and gain, again, is the increase in signal strength with respect to some kind of a reference. As this antenna's got 5 dB gain compared to a dipole, 5 dB gain compared to something else. Right? Sometimes we'll just say it's 5 dB gain for direction. So on the little handheld radios, we have these little antennas like this. We call them rubber duck antennas. So basically, it's like a little coiled wire inside of a rubber housing. It's called a rubber duck antenna. Very flexible on those handheld transceivers or HTs, walkie-talkies. Disadvantage that are not as efficient as full-size antenna. Okay, but that's good reason not to use them in a car because number one, the antenna is already weaker to begin with, and the car is kind of like a shield, so it's not going to work very well if you're outside the field. And there's a question about, hey, properly mounted 5/8 wave antenna on the outside of the car could be a whole lot more efficient and more radiated radiation.
So with the polarization, people walking about this way.
Okay. Yeah, absolutely. So, but yeah, it all depends on what it's reflecting off of and the polarization that bounce around and type of thing. But certainly, if you were this versus this, like this guy and this guy, this will be stronger than that. So even if you're out with your kids out in the woods with those FRS radios, make sure everybody's holding them the same way with the best range. Now to get your radio signal from your transmitter, your radio, to an antenna that's so mounted antenna, you need something called feed. There's a couple of different types of feed line. Oftentimes it's this coaxial cable, kind of a form of shielded wire that briefly described earlier. We've got a conductor here, another conductor I can describe. It's typically used because it's easy to use. It requires a few special installation considerations. Well, I should say it requires a few special installation considerations. By the way, drill a hole through a wall, put it through a wall, something like that's not a problem. Run through something that's metallic or tied off to the power or something like that, not a problem. Not a problem. But it does require some special coordination. Mainly used to carry the RF between the radio and the antenna. Loss in the cable. No cable is perfect. You will let some signal loss through it. Okay. And that loss gets worse the higher you go in frequency. And the impedance of a feed line is really related to the geometry of it. Okay. Most common feed line impedance is 50 ohms. I say, well, it's just a while, but even it's 50 ohms. A little bit of a complex topic, but what it means is that, think about, we talked about a capacitor, no current flows unless voltage is moving. You can almost think of this coax as a long tube capacitor, a conductor with an insulator and another with a big capacitor. So as I change the signal going into it, that capacitor cable is being charged and discharged. So the amount of current that it takes to do that with respect to voltage is the impedance of it. That's what that means. It doesn't mean if I put a millimeter on it, I'm not going to measure it. Between these two conductors, it looks like a little circuit. But RF signal, it looks like just. Have you ever, sometimes you see a little twin lead that used to have for the old rabbit ears, flat twin lead that's typically three. It's just, yeah, it's just two wires, but at those RF frequencies, it looks like 300 volts. Again, the cadence is that opposition base. So it's kind of a chart. It's just pieces. So again, common coax types. These are the terminologies that are some of the more common coax types. RG58, lots of military designations. RG8, RG213 are the most common. They generally refer to the geometry, how fat the cable is, and thin it is. All of these types of 50-ohm cables. RG58 is thinner. It's easier to kind of move around, especially used for mobile applications. Thinner, easier to bend. But it is higher loss than the heavier cables like RG8, or RG230, RG58 is over 4. So coax with the lowest loss for VHF and UHF is generally what we call an air insulated particle. Big fat cell power. Big fat cables go up. They're typically these air insulated particle cables. They'll bend very easy, but also very low loss, especially at the cell phone frequency. VHF is generally the higher you go in frequency, generally, unfortunately, the coax gets fat. Head is small, coax gets fat. Right? So again, you get this loss. Again, cable loss increases at higher frequencies, regardless of and causes of loss can be just the construction of the cable itself, but other causes of loss can be other things that can happen. Water intrusion between that insulator, mess things up, can create an high SWR. So we'll talk a bit about SWR, or standing wave ratio, later. That also increases the amount of loss. And then having more and more connectors in line will also you do connectors well and connect them and repair them properly. Well, additional connecting probably won't affect you that bad, but couple common failure modes for coaxial cable. Moisture contamination, somebody get cracks in the jacket from the ultraviolet water get in there, or the conductors. The jacket is going to be used outdoors, really needs to be ultraviolet resistant, so it doesn't break down in the sun. And then air core coax requires special techniques to ensure that the air gap in there doesn't compensation for it. Now, of course, these coaxial cables need connectors to connect up to your equipment, to your antennas. Okay. For HF use, the most common connector type is this type here. It's shown it disassembled, the outer shell and the inner part. It shows it like the semiconductor and the shield. And it just screwed onto the main connector. Called PL259. It's the most common for HF and HF use. As you go higher in frequency, it's the next most common. Again, typically not the most suitable at higher frequencies. What's really interesting is that PL259 is the technical part number, part name for that connector style. It's also kind of known as it's called a UHF connector, but oddly enough, it's not good for UHF. It's called UHF connector, but it's not really used for UHF. For UHF and above, you're typically using the red connector or another small connector called an SMA. And the exam is going to talk about it. The connector looks like this. So that typically is most suitable above 400 megahertz. And again, for all these types, you just want to take care to seal them up when they're outdoors. And you want to keep them tight. Loose connection cause a rag. Some long beams, which talk about. I'm sure there's a section. So what's standing wave ratio? Well, SWR stands for standing wave ratio. And really it's a measure of how well matched a load is, like an antenna, to the transmission. Talk about the transmission line having say at 50 ohms. Ideally, we want the load also have. But don't, you get reflections. You ever sat, sat out in the day and put the bulkhead, you see the wave come in and crash into the seawall, and then it bounces back out. All that energy doesn't get absorbed. That's what can happen to RF if the load doesn't match. So that's the feed line. The feed lines, they fit the ohm, so I've got voltage that's varying along, the current is moving along, and that voltage has got a 50-ohm relationship. If I hit the end, it doesn't have a 50-ohm relationship. Say it's a higher impedance. All this current says, hey, that's a higher impedance, but it go higher voltage. My voltage says, oh, wait a minute, I can go this way. However, it's like that. Okay. Now, because you've got some signal going this way and some going that way, at any point in time, they add up. Okay. And they can add up in this constructive, destructive way and create what we call a standing wave. All the energy is absorbed, nothing gets reflected back, then the voltage across that line is constant all across. So if I get some energy going back, then as I walk down the line, I have this constructive and deconstructive addition of that signal to create this what's called a standing wave across the line. Okay, and then the ratio of that standing wave, full wave, called standing wave ratio, is measure of that. Okay. Yes.
Wave goes through coax, so is it like a wave guide that bounces between the core and the cover?
Well, the voltage is varying. It could be like if it's like a two, then the voltage is very equal on both. If it's coax, then we're going to come up with the outer shield is staying still at the inner one. But then as I hit the end, I could get some reflectance coming back if that move grows. So what we want is a low standing vibration. That indicates efficient power transfer to the loss. We get losses. What Joe will be talking about is weights and vinegar. So again, power lost in a feed line, regardless of whether generally converted to heat. Right? We're talking about a transmitter got 100 watts of power, it's still power. And loss of the product typically resistant losses which tend to heat the coax, but not the point where you feel it. But that's the form of the losses. The whole energy's got to go somewhere. Right? Either radiated or pulsed. It's like power from your car engine, right? It's going to the wheels, pulling your car forward, or it's lost of heat out the exhaust. Okay, I'm going to talk about how to measure SWR. It's typically done with an SWR meter. Sense. It can also be done with something called directional watt meter, this guy. So the SWR meter is connected between the transmitter and the feed line. So the transmitter, I might have a short feed line to the SWR meter, and then I'll, and from there I can actually use this meter to measure how well that the directional watt meter can also be used to determine if it's done properly. Directional watt meter like this guy here is kind of the industry standard. There's this little slug that you turn around to measure power going in that direction. Turn that little slug. So that's your SWR meter rated for the frequency and power level that you're operating at. That's what you use. So I'm looking at a 10-meter radio, 30 megahertz. I'm going to make sure the meter I'm using is rated to operate at that frequency. And it's also rated to operate at the power level. Yeah, it's a little bit more complex than that because it's not DC, right? That's the whole basic signal. So, but diodes are involved in it, but it's a little more complex. Same concept. So SWR of 1 to 1 or 1.0 to 1 is a perfect match. No energy is coming back at all. An SWR of 2 to 1, okay, where most modern solid state transmitters will say, hey, I've got some energy coming back here. Once I've got an SWR greater than 2 to 1, I'm going to start reducing my power so the reflected power doesn't damage. But anything below 2 to 1, like 1.8 to 1, 1.6 to 1, it's all pretty acceptable. When you get above 2 to 1, sorry. So again, 4 to 1 means there's a pretty large mismatch. These are specific examples of. And then an antenna tuner with a device like this is something that can be used to help solve that impedance mismatch. Now, it's a little bit of a misnomer because it doesn't really tune the antenna. It's really an impedance transformer to kind of make the transmitter see what it wants to see by transforming the impedance. And generally, they're pretty low loss. So even though it's only in the transmitter to see what it wants to see, it's still doing it in a way by essentially adjusting the amplitude phase of the signal going through it, so it all gets coupled out to the antenna system being collapsed. So it's not a bad thing. So people say, "Oh, it's spooling the transmitter and make it work." Like, still got to do it. You're not really changing the SWR. That's true. You're not changing the SWR from that point to the antenna, but you are making it more efficient from getting it out. You will still have increased losses in that peak point, but you will make the transmitter pull up, but not full power. It will be transformed into that antenna system. It will still work well. Right? So the antennas that I use most of the time at home are completely non-resident. They've got really horrible SWR. I use a tuner in my shack that can get me there. I thought, oh, couple other ways to make measurements. You can use something called an antenna analyzer. As opposed to sticking something between your transmitter and using the transmitter with the signal source to measure SWR, an antenna analyzer can measure SWR by putting out its own very low power signal and measuring the reflected back going on the transmitter. The nice thing about this is that they're very low power, so you're not going to radiate anything that's going to affect or interfere. So they can measure SWR, but oftentimes these contain multiple other functions to measure things like resonant frequency of the antenna, resonant match. You can also measure things like capacitance and inductance, like the complex values we talked about earlier. So they can form additional functions beyond just measuring here. Should be the SWR and well matched. Another thing that you'll find in your shack is something called a dummy load. Dummy load is really nothing more than make critically element resistor. And typically in a resistor in a bucket of oil or a resistor with a bunch of pins on it, so it dissipates power. And the whole idea here is to allow you to do some testing on your transmitter, maybe at full power of the transmitter, maybe 50 watts, 100 watts, but not radiate something, but not interfere with something that's testing something. That's typically what it. So again, it's typically non-inductive as opposed to inductive. The whole frequency changes the frequency. So it's typically non-inductive and has a heat sink kind of dissipate the power. Probably a good time to take a break. Okay, just because we have been going now for what, an hour and a half or two. Yeah, so it's 11 o'clock. Why don't we take a 10-minute break? Back about 20 after. 12-minute break. Okay. Everybody good so far? All right.
Very helpful.
Good.
Started cramming last night.
What's that?
Started cramming last night. My wife, girls got through all the girls on ham radio.
Oh, really?
She's taking the test and she's already.
Okay.
When is it? It's like tomorrow.
I'll shave my way into it.
Yeah.
I'd love to shave my. Okay. Yeah. Jesus. Another Alan. Okay. Like passed away. Okay. It's oh, really? Okay. This is the Northeast. Yeah. And, yeah, okay. He worked in chief. Okay. Okay.
But sure, it was a video.
Okay.
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 It's a big stamp. Yes.
Okay.
But it's got a big white box top and white. And the most piece of junk.
Sure. Yes.
So it's that. This is what it has.
Yes.
And I'm thinking that it was a video. So it was an 18.
Yeah.
And I'm thinking, he must have been playing.
Yeah. Yeah. Okay. Yeah. Yeah. Okay.
He was part of the structure.
Yeah. Okay.
So you can have those out.
That's it.
She's
Yeah, we come back on one.
and right, right.
And it's very relocated this time. Oh, the bus.
That's the first one.
Okay. Yeah. Excellent. So,
The other thing I need to talk to this.
yeah.
President. Since I first got up. My father was vice president.
Oh, yeah.
Student members.
Yeah.
We're talking about this, lost our instructor.
Yeah. Yeah.
Talk about this.
Okay.
Okay, I have another time.
Yeah. Okay.
So, well, I gotta go over this. Is this what I looked at?
It probably was, yes. Well, was this or, the KP6 and you went on the study hall?
Yes.
Yeah.
I see you got the tickets.
Yes. Well, you want to look, I can give you the PowerPoint presentation here, you can actually use this for data, if you'd like.
We really don't have instructors. Do we have anybody that you know that lives? Or,
I know that it was Joe's new. Yeah. But probably some other folks too, I can't speak their ability.
Oh, yeah.
Instructing second.
well, you know, probably.
Yes, yeah.
Ours are not looking good to see.
Yeah, I mean, somebody else who I know has done a lot of classes like this, but it's not so in the area, but I would also. I've heard that. Depending on what it is and schedule and things like that.
The Warminster Club is doing their classes.
Yeah.
You find that more effective or less?
Well, it's obviously effective when you reach a lot of people. It's a little bit harder to kind of, I'm sure you would try to read to the audience. And it's harder when you're presenting something where you're going to be able to see everything. Right, so that's it's harder. But they can be interactive, they work and go through with a lot of that.
Yeah.
We started up with the Zooms during COVID and we're still trying to hire them. So that doing this Zoom is not a problem.
Well, I said, since I'm still on the workforce, it makes it a little bit harder.
You're still working?
I got.
Still protecting. How many years?
That's the offense. Oh, I know, as I said, I still feel like a new guy, but.
This week on Wednesday, we have another guy and one of the founders, or the last living founder, and John's K through J. Wednesday this past week. I'm never gonna make it there.
That's enough.
Sorry, I was checking. Registration for games.
Might ask Joe.
Voice guys, I'm sorry, but
Yeah,
Get it done.
try, I think you can get that up already. Right away, yeah. So that's a good do it. Yeah.
I'll be in touch. Okay, Joe?
Joe.
We get whatever results. All right. Penn Wireless here.
Hey, Joe Zorro.
You know, President. Penn Wireless. Been a member of one, so I'm handing out.
Oh, you know Doug Crum? Mike Champlin.
Is he really?
He's at the top.
His wife is now retired. She was
Yeah, I don't know.
higher up director of the shoot college.
Yeah, Bucks County Community College,
Okay.
President of Health.
Okay.
And he's the guy who actually wrote an article
Yeah.
covering UST for dropping antenna wires from UAVs.
Oh, okay,
But most of I know he's active with satellite building stuff.
okay.
Just portable.
I don't see him at the meetings too much.
Batteries.
Yeah.
I haven't seen him in a long time. I mean, like I said, he lived in those 2 houses. I could actually see his house from where my shack was in my house.
The Warminster Club for decades,
Yes.
their December meetings.
I just.
I had a member of the club years ago.
Yeah.
He had his own delicatessen or something. His own care.
Yeah.
So he would always come out.
Actually, the rest of the stuff, the rest of the stuff fascinating.
He did that for decades.
Yeah.
I've been a member there since I was first licensed. So, during COVID, we stopped. Well, this past year, we picked up again.
Okay.
And I think that's the last time we saw it. Penn Wireless, Lower Bucks, or Levittown, Langford area. One of those people that we're missing it, and it's going to be passed with real estate.
Yeah.
So it's just talking to Alan, and if we could do something, look for that.
Because Joe's still kind of working too, so. it's-
Yeah, I'm
Yeah.
still working. I'm not sure how much time I have to devote to something. That might be a good investment.
Warminster Club is doing theirs.
Yeah, well,
I'm not sure how successful they are. They always used to have a fall place.
Yeah. Yeah.
And used to run 13 weeks.
Yeah. Yeah, this is, 180 slides. This could be done over several weeks, but even though these aren't really teaching slides, we could teach to them. Here we're reviewing concepts as opposed to, but we can always expand on them. Like I said, depending on what the schedule is and my work schedule, I'd be happy to help out. I still know to run the whole thing for you.
Sure.
Yeah, and I'm in the same boat. I mean,
Yeah.
I'd be happy to help out. I hate to kick the can down the road.
Yeah.
Because I understand you guys do good things. But do you know Rebecca Mercury?
She's the one that came in here with
The
the Moore project. Yeah.
I know the
Yeah.
name.
Have you talked to her?
No, I haven't.
Oh,
Yeah.
sure did.
Yeah.
So I actually helped her out, pulling some of Alan's slides out.
Mm.
Yeah.
Yeah, the Moore project is.
She's got some folks that are lined up to do that.
Mm.
Okay.
Yeah.
I'll go look for it.
Yeah.
Well.
Yeah.
Are you going? Are you in the?
No, I just,
Go.
Yeah, same thing around. Yeah.
Jason's on his way up.
Oh, okay. Oh, very good. Okay. Well, we'll see.
Quick question.
Yeah. Question. Yeah, we can, we'll stick with one or two questions on it. I did talk about that. You did. Okay, good. All right, let's see, how are we on time here? Are we good? 20 after yet? One more minute. Do we have everybody back? See anything, or is everybody here? If you're not here. Let's get started again. Alrighty. So pick up here and start talking about amateur radio signals, modulation types, signal bandwidths, things like that. So In order for these RF signals to carry information from one place to another, that information, whether it's your voice or whatever it might be, has to be somehow impressed onto that carrier, that RF signal, so they can be detected together. Like loading the boxes in the wagon before wagon. So how do we do that? We can do that by modifying properties of that RF signal to carry that information. And typically, when we start doing that, that's a process called modulation, changing the properties and go to make it carry, make that RF signal be the carrier of that information. So two very common modulation types are called FM and PM. FM stands for frequency modulation, where the information that you're carrying is going to be included in changing the frequency of the carrier. That's effectively the other end. And then PM is what modulating things. So FM is frequency modulation. Question is in. PM is phase modulation. These are the most common for VHF and UHF, especially for repeaters. Here's an example. Here's our RF carrier signal that could be running at 150 megahertz. Okay. Here's my audio signal, much lower frequency. They're not relative to each other right now because you won't be able to see this. But you can see, for example, as this frequency peaks, as this signal peaks up, frequency gets lower. As this frequency peaks down, the frequency gets higher. So we're pulling this signal onto that one. So at the other end, we will be receiving this and then look for that frequency change. And we'll turn that back into our original information signal. So it's also typically used for VHF packet communications. FM for fundamental or primary mode that's used. You're not a
Great that I think it's
so because really, if the RF signal is just a high frequency sine wave, what can we change? We can change its phase, change its frequency, we can change that, right? So fundamentally, it's all we're doing. AM, amplitude modulation. Yeah, probably should. Where I take the amplitude of the carrier and modulate it with respect to waves. The strength of this, the way in regular cars. Okay. If you look at this in the frequency, this plot here is called a frequency domain plot, where the axis along the bottom is frequency. Vertical axis is amplitude. So if I had this unmodulated carrier, what I would have is take this guy away and that guy. That's 7 right? I have all my energy at one frequency. An AM signal, this frequency here is essentially creates these sidebands loops. And these are separated from the carrier by whatever frequency that is. So if this was 2 kilohertz, this would be 2 kilohertz above, that would be 2 kilohertz below. And these are called the upper and lower sidebands of waves. So AM is one of the simplest forms of modulation. Okay, been around for the oldest, easiest to read, easiest to detect. But it's also subject to noise and things like that. But your AM radio in your car, that's what it operates. So the amplitude or size of the RF carrier is varied, magnitude of it, and the energy that's present in the carrier frequency and on the side of it. So from an efficiency standpoint, it's not very efficient, because if you think about it, all the energy that's sitting here, it's not carrying any information. The information is being carried there and there. So a little bit inefficient in terms of its use of spectrum. Hence, we have something called single sideband. Single sideband, or SSB, is a form of amplitude modulation, and it's going back to this guy. And what we do is we eliminate, since these two are redundant, well, the sidebands are redundant, we can eliminate one sideband and eliminate the carrier and only send that. Now all the power transmitting is all carrying information. That's called single sideband. Okay. So it's a form of amplitude modulation. It's used typically for longer distance and weak signal contacts because, again, it's most efficient. All the energy that's being sent and all being received is carrying information on the waste carrier. It may be upper or lower sideband, USB or OSB. Okay, so typically on the radio itself, like there's a display from the radio says, I'm operating at 144.202.5 megahertz. Upper side. Okay. So again, upper sideband would be used for 10-meter HF as well as VHF. Typically from above 7 megahertz frequency, we use upper sideband with low sideband communications, but below 7 megahertz. A lot of tradition behind that, but that's for everything you're doing as a technician class, you need to do it yourself.
Written history case, I think it's been the opportunity to get further.
Yeah, it's just their license privileges, and again, because you have the opportunity to operate further and therefore interfere further, right? You've got to have a bit more qualifications to the device. Although there's a lot of time in this, many of see sometimes. So some properties of single sideband. So here again, we look at the frequency spectrum. Now you look at your voice isn't just one single tone. So your voice contains a range of frequencies, a few hundred hertz out to a few kilohertz. It's typical spectral content of the voice. So we can kind of represent that kind of like this. Okay, from a little bit above DC up to 2 or 2.5 kilohertz, 3 kilohertz, and where your voice energy is. So when we do an amplitude modulation of that, we get this upper lower sideband like this and the carriers. Okay. And then single sideband is essentially kind of eliminates the carrier and what it is. So the advantage is it uses less bandwidth than FM, which actually uses a fair amount of bandwidth. It also uses about half the bandwidth than FM. So eliminating half of this. So what that means is that I can pack more signals in any given frequency space. Like one guy talking here, another guy talking here, or if this guy was talking AM, he's occupying that much better. So I got appropriate way. So more people can fit on the band side. So the bandwidth we typically use is about 3 kilohertz for single sideband. Then you get away with about 2.4 if you're still pretty intelligible. Versus for the same audio quality on an FM, you need 5 to 15 kilohertz. Okay. So a lot more efficient in terms of how we're using the precious little frequency space that we're allowed to use.
The reason why that didn't switch actual radio stations simple sideband.
Well, because the method for demodulating it is like a trickier, requires actually some manual adjustment input, and FM is plus you don't, and when you get up to like for FM radio, on your radio dial, 88 to 100 megahertz, right? That's 20 megahertz frequency. So I don't care if I still sitting on 500 megahertz, right? But if I was operating at 7 megahertz and I'm only allowed to operate from 7 to 7.3, my total frequency space is 300 kilohertz. I can't have an FM signal occupy staff for a good portion of that. So lower frequencies, you got to use more respectful efficient.
Time. Or create something that's
Yeah, the other thing, FM is also, like I said, because noise will appear to vary the amplitude of the signal. And with FM, we ignore the amplitude. So that's why FM radio is. So again, another FM disadvantage is that only one signal can be received at the time. The single sideband, you can actually have a couple of people talking at the same time. It just sounds like they're in a crowded room. Okay, with FM, you can only demodulate at the time. Another mode that's often used, or I should say often used, but is available, is amateur television. And analog fast scan TVs occupies about 6 megahertz band. But we can't do that on my HF frequency ranges. We don't have 6 megahertz bandwidth going up. That's I got 300 kilohertz on 40 meters, right? Well, 6 megahertz. But when you get up to like 70 centimeter band, it's 440 megahertz. I got 40 megahertz, 440 to 440, 440 megahertz. Forget the numbers. But I can afford to use more bandwidth. So this will give me kind of video quality, like analog television quality. NTSC is a term that's used to refer to the format of the video signal itself. Right, when I was in high school, I worked in the repair shop and it used to be called NTSC, every place the same color. But it's really the baseband format of the CW Morse code. Kind of been my favorite move for the last couple of years. So
Later I talk about how.
I'm sorry.
Later I talk about how little.
No, PAL is primarily European. The phase alternating line, but it's very similar in structure to the NTSC. Just a little bit. But yeah, we're teaching this class in K or something. I talk about PAL instead of it. But our class talk about this. It's used to receiving equipment that actually switches. Okay, so very good. But the test only talks about it. Yep. So CW or Morse code. CW stands for continuous wave. A little bit of a misnomer because we're actually turning the wave on and off CW, but it's continuous wave and that when it's on and online. Okay, something like this. Okay. And we use international Morse code. And kind of the diagrammatic symbols of that. It occupies. Now, the exam will say it's the narrowest bandwidth mode. It's really not true. There are other digital modes that occupy less bandwidth. But about 150 hertz wide. How much spectrum will typically occupy the CW? Really depends on how fast you're sending. Faster you send, the wider. International Morse is the actual coding. And CW can be sent with a straight key, which is what's shown here. Where you're just hitting the key to put the transmitter on, transmitter off, transmitter on, off. Okay. Or it can be used with an electronic keyer, where we're sending essentially short transmissions and 3 times longer transmissions. Hit and a dot dash. That's that bit is 1/3 the length of the dash. That's kind of the timing. So there's most of the radios these days that got keyers built in that will automatically do the timing for you. And you have a set of paddles. One paddle sends hits, one paddle sends dots. And if you hold them, they'll repeat at the right interval, the right space. And if you hold them and squeeze them, you can insert hits or dots. And we look at like the letter X or the letter Y here. It's dot, dot, dot. I can hold the dot out of the dot, 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 but the other one just touch the bit, insert it all in. So the electronic here can take care of a lot of this timing for you. Have you send with what we call a really nice kiss, right? With really good proper timing. For some people with a straight key might accentuate the dots and something like that makes it harder. Well, punctuation marks are generally longer.
How do you traditionally do a break?
Yeah, so oftentimes we use a lot of abbreviations. Okay. I'll say GM, I'll say GM instead of spelling out good morning. Okay. I'll say TU for thank you, or TNX for thanks, or something like that. And so we use, so oftentimes a lot of the punctuations, like a period, we don't use very often. What we use fairly often is a question mark. Somebody repeats something, we use a question mark. So, but a lot of these other ones, like an axon and things like that, I don't know. I wouldn't. If you asked me what the Morse code symbol was for that,
That's your handle on Twitter.
Well, I'll just tell them. I'll say AT and then give them my Twitter. Sending AT is actually shorter than the accent. Right? The dot, that's AT. So, or you could also send the computer keyboard. So again, technician class can use CW on HF. So even though CW is no longer a requirement to get a license, once you learn CW as a technician class licensee, you can go on 40, 80, 15, or 10 meters. And these are the modes that support worldwide communications. You have to do that as a technician. CW on all single site. Digital modes. This is where you're using your computer to send messages. Typically, the computer and the radio. The computers often will take whatever you're sending, the message, whatever it is, encoding it into some type of a signal, which is an audio type signal, then gets modulated by the transmitter, usually using a single sideband mode or maybe a frequency shift keying mode or something like that. So typically data is not voice that's sent back and forth. So it's like a text messaging is a one way to think about that, if you will. Technician class can use data transmissions on this 219 when they're average rate of 1.25 centimeters. 1.25 meter damage. Some digital modes use a parity, extra code that's used to detect errors. It's just an error checking technique where you count up the number of ones and zeros, so that you can add a 0 or 1 to kind of make it in the garage. Just so that way, things that imagine, oh, I'm probably got that happen. It's not perfect. Check, but yeah, question mark. But it's typically using some kind of a program on a PC or a tablet or a phone or something like that. Do the encoding, create similar to those postulated. Detect what's coming back and decode it. Some examples of digital nodes, you'll hear some of these. Packet, IEEE 2.11, also the global standard of Wi-Fi, for example. And relatively newer modes are what's called FT8 to FT65. Actually, FT8 was actually developed by a Hamilton in the area here, and they're tailored. So the JT is Joe Taylor. That's where that it comes from. But in fact, it's funny. It was a couple of years ago. I gave a talk, RF talk on RF topic called Smith charts, and I happened to look up, and in the audience was Joe. That was pretty intimidating having a Nobel Prize winner in the audience. But he's a really nice guy.
Excuse me, it's parity, is that used to check some?
It's a form of a checksum. Yep. Same type of thing as using verification. Sure. But these are some of the common digital moves that FTA has become extremely common. You essentially have a standardized message that is kind of set, and you can kind of almost set it up to be automated. Okay, go send my thing out, and if you hear something, respond to them, and I'm going to get off. So some people are like, hey, that's not real ham radio because you're not really doing communicating yourself. But in the end of the day, it's still using your radio, your antenna, and doing all that. But there's some of those camps about like, but it is a very, very popular. What's that?
It's K1J.
Yeah. Yep. Nobel Prize winner in physics. And what they do is they actually do some coding in such a way that if you listen to the signal, you can't hear or detect what it's all about. But the decoding process actually grabs long sections of data and does some deep processing on that. So even if the signal is from your ears in the noise level of what you hear in the receiver, you can't hear anything. The computer can still pull it out. So they're also called weak signal modes because of that. So packet radio is kind of one of those, one of the first digital modes where you had your radio, computer, and then something called a TNC or a terminal node controller. Right? And the data was kind of grouped and sent in packets, sent out. And this one is where a checksum is used for error correction or detection, I should say. There'll be a header that's sent out as part of the packets, which contains the call sign who's receiving the packet. And then in that system, there's an ARQ or automatic repeat request. There's an error detected saying that the checksum didn't add up. Then the network will send an ARQ, which will resend that back. Okay, it's an error correction. So this is more of an error check. Correction, if I say that again. Another thing called APRS, automatic packet reporting system. Some people will incorrectly say this is automatic position reporting system. That's often what it's used for. Where you would have like a GPS receiver that would be hooked up to various equipment in your radio and would basically send out via this APRS network coded message that indicates where you are. And there's actually a website you can go to and say, and you can see where all these different amateur radio guides are. That's the locations. So you uses packet radio. It also uses GPS for the position system to grab that grab the location, and then send it out. So real-time document digital communications along with a map showing locations, and you actually go to the website. So APRS can transmit your position data and text messages. So it's not just automatic position reporting or an automatic packet. I see a message here. I don't want to leave the meeting.
It's fine.
Okay. Or I'll say, okay, all right. We're being spied on. Sure. Okay, so one of the modulation types for some of these digital communications is a phase shift key, where ones and zeros are going to translate into shifting the phase of the RF carrier. PSK stands for phase shift key. There's a very popular digital mode, one called PSK 31, which stands for 31 characters a second, or 31 bits a second, that's type of sending. Okay, so it's a low rate digital transmission. It's basically used to just transmit simple text messages. In fact, it's about the same speed as most people have phones. So when you're communicating with somebody with PSK 31, you actually literally see letters pop up as them. Unlike when you're looking at drawing phone, you can see the dot, 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 and somebody's typing, and you want to see until it's done. You're seeing it as it's happening. Okay. So another digital mode where it's more for voice communications is something called digital mobile radio. It uses FM, actually multiplexes signals onto a single channel. Okay. We'll be talking about it more this later. Okay. And radios are, it's the radios that are kind of equipped to kind of do this. It's really, instead of voice being encoded and frequency modulation being encoded together directly, it's coded into a digital signal, then send it out a digital transmission. So it's error correction, things like that. The audio quality is better. Any pretty things like talk root, we have messages are going to take for a certain audience. Now there are weak signal modes. We picked a little bit on this, like some of these very narrow band modes, like PSK 31, FT8, things like that, can be considered weak signal modes. And many of them will actually use the software called the SJT, weak signal Joe Taylor. Okay, but he wrote the software here too as well, and developed all the algorithms and weak signal Joe Taylor. So for things that can be really, really weak signal, bouncing signals off the moon, or the cat loss, like 40 dB. Okay, you do that, okay, we still need some antennas. Outpacks, by the way, one of the organizers of this, director here at the college, is speaking to the voltage of the Earth, getting bouncing signals off the moon, it's all about people as you see the moon is reflecting. Pretty crazy. 2.5 seconds of delay. It's just each way. Sorry? Each way. Each way. It's 2.5 seconds. It's a 2.5 second total run. Interesting. About try things. 2016 was the 70th anniversary of something called Project Diana. Project Diana was done in 1946 by the U.S. Army Signal Corps down at Camp Evans before the Fort Model. And it was the first time that we bounced a radio signal, so radar signal at the time, off the. And you say, well, what's the big deal about that? Well, the big deal up until that point, nobody knew if radio signals could penetrate the atmosphere. So that kind of told people, oh, we can penetrate the atmosphere. That kind of paved the way for space. You can't communicate past the atmosphere, and you wouldn't be traveling in space, right? So that paved the way to that. It's also interesting that Dr. Walter McAfee, one of the principals in this, did some calculations of how long it would take to come back. So they were computing essentially what effect is that they knew the speed of radio waves, and they knew how long it would take to come back, and they ran some computations that to measure the distance from the Earth to the Moon. And it was later found out that even it wasn't verified until decades later. Someone actually verified this calculation, the results, and found that his calculations were off by 60 feet out of 200,000 miles, 230,000 miles. Off by a few feet. Pretty crazy. So, The interesting thing was 70 years after that happened, I was part of a group that was at the same site. Wasn't the same antenna. The same antenna that was used was a 115 megahertz VHF radar, it's all gone. But on the same site, 100 feet away, was an 18-meter parabolic dish that was actually built in the late 50s for the first weather satellite called Tyrus. Joe Taylor, a couple other guys from Princeton, and a radio club, radio club, spent a couple of years refurbishing that 18-meter dish to get it operational again. Joe and his team and some of the other guys at Princeton were using it for pulsar research in space. But we also, on the 70th anniversary of Project Diana, to the minute, at an event where we actually transmitted a signal up the moon and bounced it back, 70 years back at the time. So that was actually pretty cool. But the gain of that antenna was so incredible that we were transmitting 200 watts to the antenna, but at 1.29 gigahertz, 1.96. And an 18-meter dish at that frequency had a gain of like 40, 60, which doesn't sound like a big number. But that means that 200 watt signal was an effective radiated power of about 8 million watts in a beam that was about a degree and a half wide. So it had to actually be actively tracking the moon. The moon moved at that apogee, was moving about a degree and a half. So we actually had the same thing, antennas on the moon to track the moon. And we were sending signals off the moon and hearing them as strong as somebody was writing. So it was pretty fun. And it's really cool because like if you got on a single sideband and you drop the cross on something, and 2.5 seconds later, you hear your voice come back and bounce off the moon. Wow. So yeah, so I was science, that was fun. But normally you don't have that kind of thing, but so you use other things. Meteor scatter, other things. FTA again is that one example. It transmits on 15-second intervals, and then the software. Another thing that could be done, digital nodes, is full mesh networking. There are two common ones here: broadband HamNet and amateur radio emergency data network. This guy here actually uses commercial wireless LAN routers, and they modify it from it. So RADN is kind of more specific. But these are typical things that clubs might set up in the event of natural disaster where normal communications are down, and some of these networks that sound wide event communications for any kind of traffic. So, but some clubs are very heavily involved in this. Personally, they're pretty involved with all of this.
But the hams providing communication and they got knocked off by feds.
Excuse me. Yeah, but because all that was such a mess. The communication was such a mess. None of that. They were trying to be clear where was there everything. So, but, yes. All right. So that's kind of where we are on just the radio signals themselves in terms of what's in the exam. Next thing we'll talk about is safety concepts. Power safety, towers, antennas, circuit breakers, all the kind of things that we're looking to see. So general electrical safety. Obviously, when you're dealing with amateur radio, oftentimes it's pretty easy to come in contact with dangerous voltages. And what would constitute as dangerous voltages in amateur radio is anything above 30 volts. So we don't consider a 12-volt battery dangerous, even though it could be. There's a lot of function. But 30 volts is kind of up there, probably like a shot. You take your fingers, long you on a soap, but put your fingers across the full battery. Shot. You get 30 to 40 volts to start. It's like, or just think about a battery and ton of built in your kit for that. So 100 milliamps, okay, so 0.1 amps of current flows through the body can close that. So it depends on where it's flowing and what it's doing, but it can close that. So it doesn't take much. That's why in places like the basement, kitchen, bathrooms, you have these circuits called ground fault circuit interrupters. What they're doing is they're actually measuring the current flowing out of one of the prongs of your outlet and then returning back to the other. And if they don't match within a few milliamps, if they should, that means that current's going somewhere else, the circuit assuming through you. So it's not like a circuit breaker that falls on an overload. This falls on the current mismatch. That's what GS does. So how does the current cause harm? And depending on the level of the current, what it's doing, it can cause heating, burns. Okay? It can also disrupt the electrical function of cells. And obviously cause involuntary muscle. One of the most dangerous is you grab something, a live wire, and all of a sudden you hit contraction. So AC power safety. Upside down.
That's right.
So 3-wire outlets and plugs are safer because they do have that ground. The third wire is a safety ground. Ideally, under normal conditions, there's no current being flown over the ball. It's all available to take the fault. The safety ground is often connected to a green wire and all the up to TAM. Typically, that would be like so good ways to guard against electrical shock. Use 3-wire cords for everything. It's not double insulated. You got the power bill says, hey, double insulated, you only have a 2 problem. Because double insulated means that any single fault won't cause you a problem. So all AC power equipment to a safety ground is holding down interlocks for anything voltage and use circuit protection. They're all going to be circuit protected by a GFCI. Area where you could become a path to ground. It's any place where there's no water or moisture. Domestic house wiring here in the U.S. Black is the hot lead, white is neutral. Back at the power source of the fuse panel, the white and the ground are tied together. Neutral and ground are tied together. So it doesn't. So it's not wiggling. The black wire is wiggling. The white one is not. But it's getting all the return current. And then the black, the only thing with the ground at the source. And then so the bare wire is the safety ground. Sometimes it's got a paper film or whatever on it. And then oftentimes you'll see it sometimes in boxes of red wire. Red wires can also be hot. They're typically used for what's called traveling wires in grid circuits. So fuses and circuit breakers, say interrupt power, we talked about this already in case of an overload. Always replace them with the same type of rating. Okay. Putting a 20 amp fuse in place of a 5 amp fuse can cause exciting things to happen in a bad way. Fire, except for overheating, stuff like that. Like that magic smoke out of things. Always include the fuse or circuit breaker in any kind of only equipment that you're making in case of a fault to protect yourself. And fuses and 120 volt AC power equipment are used for the hot. When you're working on equipment, you always want to, if you can, disconnect it from power, especially if you're removing components. Capacitors in circuits, we talked about them storing energy, storing voltage. They can store voltage even when something's been disconnected or powered down. Okay? So they can shock you when they're disconnected. So you may need to discharge them. So, and it's a good idea to work with one hand. If you work with one hand and you touch something, you're not providing a path to something. No. You have both hands in something, you can create a path, and that path is through your chest. Now, battery safety, we said 12 volts isn't necessarily a dangerous voltage. There are still things to worry about. The lead acid batteries, charging them and discharging them, you get the explosive gas that can build up without the ventilated areas. So use a 12 volt lead acid battery in your basement on the charger. There are better batteries that you have sealed lead acid battery better than the old style with the install. Shorting the terminals can cause exciting things to happen. Burns, fire, things like that. But there's a tremendous amount of energy. If you short them out with something, you're working on a car, you accidentally cut the wrench between the two, which is always nice having you working on a car just get up the ground. That way, if you have to be touching something that's 5, 12 volts and you hit the chassis, then you block. You have to be sure. And then if discharge too quickly, they can overheat. And as the power's out, you recharge them by, you recharge total batteries by making your car battery, the engine run. So it's a charge when the power's out. And when installing antennas, there's a lot of considerations here for safety as well. You want to look for and stay away and clear of overhead electrical wires. What's wrong with this picture? If this tower happen to fall, it could fall on wires. You want to keep 10-foot clearance to any power lines, even if it should fall. That's not your minimum. So if this thing happen to fall down, is the furthest this thing is away from the ground. That's still more than 10 feet away. And never ever use it until it falls with the wire antenna already. Antenna placement. You know, but as Lucy was a good place to put the antennas, right? Position antenna so that no one can come in contact with it and transmitting. Not so much of an issue with a small low power info. That's what you're actually right there. But we're talking about typically higher power, 50, 100 watts or 1500 watts of power. You want to make sure no one comes in contact with that antenna. Our burns are painful.
And is the receive also cut? Just
Just a trick. If it's such a receiving moment. No. When you're working on towers, be sure to have proper training on proper climbing techniques and use of safety equipment. Always tile for the tower in a redundant way. So if I'm climbing the tower, I've got 2 hooks on there so that when I'm repositioning one hook, when the other is still attached. Always use a climbing harness. And use a gin pole to lift tower sections or antennas. Gin pole is like this pole that's kind of up the top of the tower section. You bolt that up there, it's got a pulley up there, and you use that to lift the section to bring it up. When that's done, you climb up further, you pass the gin pole. You're not sitting there pulling something like this. You want something from the ground, hoist something up to the gin pole. Everyone wears a hard hat, same process. Dropping a, you got a quarter 20 volt from 60 feet up the tower. So never climb alone. And crank up towers, if you have those kinds of things, telescoping type of things, you want them to be fully collapsed. Working on them, or have some kind of a mechanical interlock so that if the lifting cable fails, that the thing doesn't come down the shear, your fingertips go on. And then safety wires and turnbuckles are used to tension guidelines. So because over time they may just not work. Just a short list of few of the considerations. Now, for towers, you generally want to do a pretty good job of grounding them. It's not necessarily for preventing damage from a direct lightning strike. That's a really help that. Okay, but really, what the proper grounding antenna does is it leads off any of the static energy that might build up that make the tower a target. Okay. It also will help with partial hits and things like that. So very important. The tower is a big lightning rod. Okay. Lightning rods on houses aren't there to get hit, but to protect you from a direct strike. Direct strike is still going to do some damage, right? When they're doing it to prevent getting hit. Like so local electrical codes will have guidelines on what for the grounding. Those consult those. Typically, there are separate, at least 8-foot grounding rods per tower leg. Is kind of a starting point. So you've got a 3-leg tower. You have at least 3 8-foot ground rods, something ground. You're going to strap both of them, add both together, bond it all together. It's very short and direct connection. You kind of see here, I got these copper straps that unlock to the ground rods. Avoid sharp bends, and then all ground rods and earth connectors should be bonded together with wire. And then lightning arresters on the feed lines are always a good idea. Again, you just get static buildup, they can put in and damage arena. Charges, as well as this energy you get with nearby shapes. Now, RF exposure, this is something that, the last couple of years got a bit more attention. So now every station licensee is required to perform an RF exposure evaluation. And, yeah, the ARRL has made this actually easy. They've got a website, you can plug in the various parameters, the frequency you're operating at, the antenna, the power that you're running, spit back out, minimum safe distance, for people to get to, that can come near your antenna without having a problem. So you just have to kind of run that survey. Nobody ever going to come look at it, but you're required to actually for your own safety. If you decide that, hey, looks like, my configuration is antenna that I'm using, I got to make sure that nobody can get within, 10 feet of this antenna. And if you wait that set up, someone can walk up to it and touch it, then you probably want to move. So even though radio signals are what we call non-ionizing radiation, with ionizing radiation because actual chemical changes, damage DNA, even though we're non-ionizing, it's still something we want to consider. On VHF, you can run up to 50 watts of power at the antenna without performing an exposure. Peak envelope power. So with a single sideband, if you can't radio don't save them, transmit those out there. So they would measure power as peak envelope power. Where your voice peaks, what's the highest power that's achieved? So again, the RF exposure evaluation can be formed based on calculation. There's an FCC bulletin that's out there. Tells you how to do the calculation manually. You can also do computer modeling, but again, there's websites now that you just plug in information results. Right, or it can actually make some actual measurements of field strength. Most people don't. Again, to stay in compliance, whenever you make a change, stands on an operating on a rated basis, or I can't think of time you want to read those calculations. So part of the calculation involves something called duty cycle. Duty cycle is the percentage of time that the transmitter is transmitting. Okay, so when you sit down the radio, are you listening 90% of the time, 10% of the time? Okay. So it's factored into the exposure because it's really the average exposure level for the time. It's a available power density for our safety increases by a factor of 2 if we go from 100% to 50%. The average exposure. So the exposure limits, they vary with frequency. The human body absorbs more energy in some frequencies than others, so it's not based on that. The 50 megahertz band has the lowest permissible exposure. Bodies are most sensitive to the blood back. And the factors that affect exposure are the frequency and power level, distance from the antenna, and radiation. That's all factors. So keep exposure safe. Relocate antennas if you have to. Lower your power levels if you have to. Transmit less often. That's what. And reevaluate. This is where I stop. So what time is it? Is it lunchtime? Should we take a quick lunch break?
12:03.
12:03. Should we take a quick, like a half-hour lunch break and then come back? Is that good? Good for everybody? We'll do that. See you soon. All right. The tests are, they start 3:30?
3:30, I think, start
Yeah.
the exam.
Yeah. All right, like I said, we'll go, like I said, Joe's got from here to the rest, so he doesn't have as many slides as I talked about. You've got 70, 80 slides or so. They go pretty quick, and then what time we've got after that between that and the test the exams, we'll do the final Q&A and run through a couple of practice exams just together.
Practice
All right. I'm gonna switch over, put your presentation on here.
Great vote. Welcome. Those targets. That's okay.
I don't know why that security alert
Yeah,
keeps
I don't-
coming up.
Yeah, I don't know either.
I saw that on my machine as well.
Okay. All right, so you're good to go starting here.
Yeah, very good.
All right. I'll put that. I'll put that back on my thing, 'cause you're not gonna use the clicker. You said you're gonna stay
I'll
here.
I'll just stay here. Do it.
Oh, for those of you
What
guys
is
who are
it?
still here, I'll mention it now, I'll mention it again, like back. On the table here, in addition to the materials that Rebecca dropped off about the wall project, there's also some flyers here. One of the things I'd like to do is to have like flea markets. And more of a strategy for flea market, they have those, is actually come back from there. So it's a fun. Yeah, so those people have, you know, people sell radios, parts, DVDs, talked about earlier how people sometimes exchange cards. That's the part that I use. That's so. My call sign actually use a.
Now, I was going to ask you
Yeah.
if you wanted me to bring some cards. It's a tough thing to concentrate on.
Yeah.
Yeah. But I have one from KC4 USA.
Okay.
A South Pole Station.
Yeah, yeah.
And it's old and
Oh,
the guys are shaking hands.
oh, really?
In the 70s.
Oh, wow. I've got KC4 AAA,
Oh, wow.
which is South Pole Station.
Oh, cool.
So, they're at the Scott South Pole Station. I'm not sure if USA was in the same location or not, so.
We don't know. But I'm going to send you and send you.
Yeah, the KC4 AAA, is at the Appleton Scott Station, which is a visual site of the quote unquote visible pole at the South Pole.
Oh, wow. Cool.
So what is this?
Oh, it's just a goofy thing, where basically saying how engineers
I used to
are
go
really
to-
good, aren't good spellers, they're just too much in the technology. I used to put spell engineer. Oh, really? That's a goofy thing.
This is a machine shop. This is a.
It's still not bad. Okay, now, this is all. Does he work like in that?
He's in Union Off-Road office.
Oh.
26.
Okay. There's a. Aspen and the man.
Oh, yeah, he's over there too.
This is less. Okay.
His father worked at this is the way that I found it.
So stop that. Stop there.
What's up? 100 so
Oh, really?
yeah.
Okay.
Like the line. Okay. I've actually had it on 20 meters. Anyway, Chad. You work with two adults, this is funny, and the ones. It's the voice of it.
Oh, really?
But he also wrote the single side. He wrote the part. Basically.
Oh, really? Okay. So like, simple electronic stuff.
Yeah.
Yeah. Less shown. All those guys.
He was the designer.
Wow.
Right? Actually, what the.
Yeah.
How's it work for paying for? Well, they'll talk with the VE team afterwards. I'm not sure if they take cash. I don't know if they're taking. There's really two things. You pay the VE team, they're $15, but then there's also a fee that you pay the FCC, which I think you go online and do that.
I don't know if he collects that now. Or if he actually.
I think the 15 are collected out for the VE team, but I think the other one, you get a notification from the FCC that hey, the license is ready. Okay. So, but the VE team will still get on all. All right, good, thanks. And the test is around 3 or something. I think
Maybe 3:30. So it's advertised to start about 3:30, so we call it. These ago.
Oh, I guess. Probably take Joe maybe an hour and a half to get through the last
Yes.
slides, and then we'll spend the rest of the time doing that session, doing some practice. Okay. So good.
I'm gonna try to make it shorter than an hour and a half, so you have to try to see this. Testing.
Okay, it's good. Really good.
Yeah, the rest of this stuff is fairly straightforward. Some of it's numbers.
Yeah.
Some
A lot
of
of it's
it's
common
regulations.
sense. A lot of it's common sense.
Yeah, I've been doing practice.
Good.
I don't know if I'm gonna sit here because I'm getting a little confused.
It's okay.
All
It's all right.
Like,
Whatever, everybody learns differently,
Yeah.
so. no problem.
Yeah.
So,
okay,
thanks. All right. Absolutely.
and
I know it's.
all
right.
Sorry, I'm late.
That's okay.
I talked to Rebecca
Yes.
and she told me to just pick up the flyer.
Okay.
So I had already missed like 1/3 of the sessions.
Yeah.
So,
You're more than welcome to sit in, you know, and even take a test later on today after the testing session that you kind of got all the pre-work. If not, just consider giving it a turn. You're more than welcome to sit in.
yeah,
We're gonna pick up again at 12:30.
where can I find the material? Is it just like all
So-
these websites?
Well, actually, if you go to the flyer, all the information for the computer festival itself, there's actually a link there to download the presentation as well as the study guide.
Oh, cool. So I'll write that down.
And I know Rebecca with her board project, that's what the brochure you picked up, they actually do a more. There's actually some advantage to going through their class if you don't want to actually try and get the license today. Because if you run through their whole class and you get successful license to the class, they actually give you a rating.
Oh yeah, that's what they were telling me about.
Yeah.
I want the radio. Yeah, I think
So-
I'm gonna do that.
But if you want to sit here to kind of get familiar with some of the
Yeah.
material, great,
Right.
that's an obligation.
Oh, so this is like a whole 6-week thing.
Yeah, so they teach you the material. There isn't enough time in the 6 or 7 hours that we have here to
It's
teach
just
you
like a
all.
review.
This is a review of the material
Okay.
to really kind of help you identify those areas that you might have a little bit of confusion or that type of thing. Here's some of those things up. there's no time to kind of teach all. the
This sounds
concepts.
cool. I think I'm gonna do this. I kind of want the radio. What kind of radio is it?
It's a handheld, VHF, I think VHF, it's cool name, but the VHF, UHF handheld FM transceiver. It's like
That sounds so cool.
That's a Yaesu transceiver, which is one of the kind of the big name brands. It's a couple $100. Can you really?
Yeah.
So.
Thank you so much.
Yes, Alan.
Cool. Joe.
Nice to meet you, Joe. Thank you.
Take care.
Yeah, so this, so which of the problems is appropriate power supply for the radio?
So you need 50 watts out.
But the key here is that mobile radio.
Yeah,
They're saying
radio
the
is a
mobile
good
radio typically uses a 12 volt supply, 13.8 volt supply. So 13.8 volts, they're the range. So two that would say 24 volt means, okay, that's not the voltage. So there'll be the 12 volt, and the 13.8. So it needs to be the 13.8 and four, it's just 13.8 and 12. How much power does that deliver? 13.8 times 4 or 13.8 times 12? Which one of those significantly exceeds 50 watts? Because
Because it has to exceed.
has to, because that's to go deliver more power. The radio's not gonna be fully efficient. Without
Okay.
putting 50 watts, the radio's gonna use more than that to generate. So 4 times 13.8 just barely gets you into 50.
Why,
Right.
so if we're talking 12 volts, then I, was at 13, it's close
Because-
enough.
Yeah, because a 12 volt car battery and fully charged is actually 13.8 volts. So you're getting, yeah, of course.
Sorry, guys, it's like I.
All right, absolutely, yes.
Yeah, it's very, very good.
I'm gonna go grab something myself and come back and do something.
No, my classroom chicken.
I was actually
Not mine
gonna
either.
address this
Make my own
piece
rules.
of it and say that that's your power output. If you multiply these two together, you get more.
Right. Yeah,
So this is like 30% efficiency. Where's the power going? You don't. Make, when you do your installation, you can make sure that you've got some ventilation. Otherwise,
Yeah, because this one gives you 55.2.
Right.
But that assumes that this radio is close to 100% efficiency. So it's all how it power.
Very interesting.
We're gonna-
Thank you. The other question that you have is, are you gonna be involved, have you been involved with Mars?
I haven't. But
years ago.
Okay. How many years? The 80s?
Well, I had, yeah, probably 70, 70.
In the 80s,
We didn't even know. I've got contacts in Mars.
no, when I was first in the Navy, first deployed, you know, that we were out for like 4 months, so I set up a Mars station aboard.
Yes.
I had just gotten married.
when they were in the packages and stuff like that.
And then, yeah, so I waited an hour in line, it was, hey babe, how you doing?
Yeah.
Okay, time's up, next guy.
Yeah.
So,
Do you ever see the rocket that's installed? It was deep in Saudi Arabia.
oh, really?
Yeah,
Okay.
and you run it with a resistor, you have a nice clean beam to you know, this was open for 4 months. Take the resistor off and you can do the south.
Well, thank you very much.
Let's say that.
Yeah, go ahead.
Yeah, sure, go ahead.
You're allowed to use calculators for the test?
As long as it doesn't have any number.
Yes, as long as they're not cell phones, and it's only using zeros.
On power, I got 165 for the 12, 55 for the 40. Okay. I wrote down the 55 inch is too close because of the house.
Exactly, that's where, I just did this last night,
Oh, okay.
and I remember it was like 130. Oh, no,
I thought 160.
165. Okay. Yes. And that's the answer.
It is.
Yeah, 165. So if you take the ratio of 165 to 50, it's like 30%. That's not 50. Right? Okay. So, and if you just do the subtraction, 165, take 50 out of that. That's how much power it is.
Just a people calculator.
So, yeah, that's what they're asking. Okay. Not like cell phones.
Okay. Yeah, thank you very much.
Absolutely. Yeah, we're gonna start back up again at 12:30, so we'll get people be talking here. We're welcome to sit in.
So check. This side. I'll text you around. Yeah. Okay. Thank you.
The one question talks about excessive gain. Are you amplifying transmission? Amplifying too much? Excessive. Thank you.
2 thirds. Yeah, it looks like 2 thirds. Sorry? 2 thirds. Yeah.
Okay, we're gonna pick this up so that we can get through some of the material, get through the rest of the material, hopefully be just over an hour. And then go into some of the practice tests. So we're gonna talk about the station setup and operation accessories. Dealing with interference, some of the station equipment and some repair and testing techniques. Okay, one of the things that you're going to probably need for at least a base station is power supply. And when you wire the power supply to your radios, you want to make sure that the wire gauge is heavy enough to carry the current. And a typical 50-watt mobile radio at 13.8 amps at 12 volts is what you would need for a power supply. We just had a discussion offline that if you use the Ohm's law equation you learned earlier today, you multiply the current times the voltage, you get about 165 watts being supplied to the radio. That radio delivers 50 watts to the antenna. So where did the other 115 watts go? Well, it went to heat. It's part of the efficiency factor of the radio. So just beware when you make your installations that you got to leave some area for ventilation to dissipate the heat of your equipment. Headphones are always nice to have in noisy areas. Some have a boom microphone like the one in the picture, and additional microphones with the connector for push to talk circuit, so that you push the key and the radio switches from transmit to receive, or you activate the transmitter and mute the receiver if you have separate transmit and receive boxes. Okay, computer is always helpful for logging contacts, connection to the internet for looking up information on the call sign that you might be working, sending and receiving CW, the Morse code. Use the connection to the sound card, and some computer programs are out there to decode the Morse code signals or generate the code from the keyboard. And generating and decoding some of these signals, such as Alan had talked about, the PSK31 and the JT series of weak signal programs that are available. Again, the digital modes, you normally use the computer audio in and out to interface to the radio, and also to key the transmitter. Now, sometimes if you don't have a keyer, use of a box or voice operated control will key the transmitter for you as soon as you light the signal. But that's kind of a hit or miss depending on how well the box is set up and how much audio power you have to drive it. FT8 is an example of the audio that can come out of the computer and into your transmitter, and usually the line in and line out connectors. Okay, one of the things that you may need as an accessory, but more and more of these terminal node controllers are actually done by the sound card. Per packet, terminal node controller converts the ones and zeros in a digital mode to audio tones, and it works in reverse on the receive side. It converts the audio tones from the receiver back to the ones and the zeros that the computer uses to decode things like frequency shift key teletype or RTTY. And again, it's just reinforced here in the verbiage that the sound card performs a TNC modem function. Okay, interference. Sometimes you can be the victim, sometimes you can be the source of interference. And one way to eliminate or at least reduce that is to use the ferrite snap-on beads that are available around some of the interconnecting cables. The idea there is that it breaks up the electric field that's around the cables to either reduce the RF flow on the shield part or on the audio conductors themselves. The other interference mitigation step would be a low-pass filter. A low-pass filter is one that has a cutoff frequency, and everything below that cutoff frequency will pass, and frequencies above that cutoff frequency will be attenuated. That's particularly handy if you're going to be working on 10 meters. A lot of the low pass filters that are available cut off at about 30 megahertz. So that anything above that you might be interfering with, where your harmonic multiples wind up into the FM broadcast band or in the TV broadcast band, they get reduced from your transmitters as being the source. This is left over from the over-the-air TV reception days. A band reject filter on the antenna line coming into your television set. A lot of times folks have cable or have satellite connections coming into the residential TVs. So this wouldn't help you there, but if you're doing an over-the-air reception kind of a thing, this is a handy gadget to keep in mind. Okay, grounding is always helpful too. Short, flat strips are usually the best kind of a thing with braid to use. Want to keep those things as short as possible, and connect all the equipment to a common ground if you can, around the shack, or if you're going to install in the automobile, right to the chassis.
There's a picture, just did this that.
Hey, there you go.
This truck, my friend Sue, she installed an antenna, there's that ground spot.
Why is flat?
Really what you want is to keep the cross-sectional area of the conductor as much as you can give it. Okay,
Yeah,
so it keeps the
don't have
impedance
close
low.
on the surface. So round wires are gonna have as much surface area as a braid.
Okay. For the positive supply, if you can get right to the battery or to the, some cars have a secondary fuse block inside. You can get to the connections on that fuse block. That'll get you to the battery directly. It's generally the best method in order to keep the path of the conductors short and keep the resistive losses low. Alternator wind might appear in the audio, and that's generally varying with the speed. If you increase the speed of the motor, the RPM count, the whine will generally go up in frequency and fall with when you take your foot off the accelerator. And filters will help out with this as well. Ignition noise sounds like a ticking sound at idle. That'll pick up with RPM as well. And noise blanker, if you're using an HF radio, mobile, for example, on 10 meters, to install a mobile radio that had 10-meter capability. Battery operation. Car battery is a good source for stationary if you're doing portable kinds of work. The life of the battery, how long it's going to keep your radio on, is going to depend on the capacity. It's generally specified in ampere hours. We divide the battery ampere hour rating by the average current drawn on the equipment to give you an idea how much time you have on the battery. Some of the common operating controls, there's one for the mic gain. If you put the mic gain too high, that will overdrive the amplifier and you'll get distortion on your signal as a result. The audio frequency control or audio frequency gain, that's just a fancy name for the volume control. Usually a control on the front that sets the RF power output. One to set receiver gain, which is kind of like the volume control up front for your receiver, your signal that delivers more signal from the first stages of the amplifiers after the antenna into the rest of your radio. A lot of times, if you have strong signals that are close by where you're trying to work, you get overload. You can reduce that by reducing the RF gain. There's an AGC circuit that tries to keep the received signal on your audio at a relatively constant amplitude, so you're not always raising and lowering the volume control. Some radios actually give you a selection between fast, medium, and slow responses for the attack and decay time, so that gain control to kick in. And squelch, in this case, we're talking about squelches come in a couple of different flavors, either level control or tone activated. In this case, we're talking about level squelches that mutes the receiver when there's no signal, so you don't hear a whoosh when there's no signal. You don't want to set it too high because it can miss signal. So the trick is to adjust it just until the noise goes away. Okay, and a receiver incremental tuning on some receivers allows you to fine tune the signal that you're trying to receive without retuning the center frequency of the receiver. And there's a clarifier that's helpful in signal sideband pitch reduction. It's too high or too low. Yeah.
The materials it talks about which of the following can be used to enter a transceiver's operating frequency as a BFO. Is that the same thing as a RIT?
No, BFO is
You said BFO.
BFO, B frequency oscillator. I'm sorry.
It's a variable frequency oscillator.
Yes.
So that's actually your main tuning.
Yes.
Okay.
Okay. Noise blanker.
Oh.
It's
That important,
it's important to know. Noise blanker will try to keep the impulse noise out of the receiver,
So,
like ignition noise. Yeah. Okay, some more on the operating controls. The HF transceivers have a selection of filters to match the type of signal that you're trying to receive. Examples of those are 2400 hertz filters for speech for single sideband, and 500 hertz for CW, the narrowband Morse code. And the key here, Alan had mentioned it earlier, but no, I didn't touch it.
No, I think it's time's out after I got to turn it back on again.
Okay. This happened last year.
Yeah, right about the same.
Right
time.
about the same
I think it's
point.
like, doesn't like being on for
It
like
doesn't
5
like
hours
me.
or something, and then you have to turn it back on again.
But the point is with the communication circuits, especially in HF, where you have noise fields that can vary from hour to hour, minute to minute. If you really have to get a message through and you want to get it through, CW is the way to do it. It's slow, but you can get CW, you get Morse a lot cleaner than you can get a voice through at lower signal to noise ratios. And just as an aside point, if you look at the radio navigation stations for aircraft, all of those stations are identified with Morse code at the rate of about 3 words per minute. That's because it's easier to pick them up than it is to pick up a voice signal. No, this is a VOR. The IFF is transponder, but the VORs and the TACANs and the ILS components all have Morse identifiers associated with them. And that actually becomes important when you're trying to discern which frequency you actually tune to because of channel reuse. There's just a limited number of channels available for VORs around the country. So they share channels. You want to make sure that when you tune to and you're navigating to a beacon, that you're navigating to the right beacon. Okay, thank you. Okay, and the question about the VFO, variable frequency oscillator. It's the knob or the keypad entry. And a lot of transceivers have memory for storing favorite frequencies for easy access. most of the radios with the memory will allow you to automatically scan through the stored frequencies to find the activity. And fine tuning above and below the frequency can cause distortion, especially on AM or FM sideband, or on FM or single sidebands. Okay. Offset frequency is the difference of a repeater's transmit and receive frequency. We haven't talked a lot about repeaters yet.
I think I
But-
mentioned it once.
Alan had mentioned them, and the reason you use repeaters is to extend the radio line of sight between two stations that are on the ground. They're typically located high, and the way that they work, we'll talk about in some detail. But there are several types of repeaters as well. One with the transmitter and receiver located at the same position. And there's a system called a voting system where you would have one transmitter and maybe a receiver located with it, but multiple receivers scattered around the geographic area. And the idea there is that it's high, it's got a lot of power to transmit to your low frequency handhelds or mobiles. And the mobiles are located in different positions where they can hear that transmitter, but the transmitter can't hear a lower powered mobile or a 1-watt handheld. So what they'll do is take the signal strength, link it all back to a central location, as well as the received audio, and just retransmit the signal where the computer determines you have the highest signal to noise ratio, the best signal coming. It's called voting system. But the repeater will listen on one frequency, transmit on another frequency, and the difference between that is called the split or the offset. Okay, and that becomes very important when you go to program your radio, because number one, you have to know what the offset is, and number two, you have to know what the offset direction is, whether it's above or below, whether the repeater transmits above in frequency or below the frequency that you're hearing.
That someone's saying they're broadcasting a specific signal. Is that because someone's saying they're broadcasting on a specific signal, but you need to hear us at the offset?
Yeah, but well, the repeaters
Yes.
generally are kind of assigned. Actually, a book that's got all the frequencies.
So they're all.
You know, I want to work with the repeater that's operated by this plug over here, this is the frequency here they use. And it'll tell you what their transmit frequency is and what their receive frequency is. And so, unlike when you're operating a jet, where you're just free tuning, trying to find a good spot or find a good spot. Repeaters are generally on known frequencies.
Yes, and for what's coming is when you go to operate a repeater, if you're looking to make up a call, you would drop your call sign. You would say listening on, and then either the repeater output frequency abbreviated like 6-7, or listening on N2RE, the call sign of the repeater station. Because a lot of folks are scanning through and they hear you call, you're looking for a conversation. Well, where was my receiver when it? We don't know what frequency we heard you on. So if you drop your call right after that, it helps the confusion somewhat. Okay, and the reverse, something called a reverse split, is that you can toggle between the receive and transmit frequencies on your handheld. So sometimes if you're having trouble hearing a signal on the repeater, if you tune and listen to the input signal that repeater is listening to, you might be able to hear that signal better than what
I
you.
think I might be closer to you than just computers. Say, hey, switch to simple.
And by the way, that's an answer to one of the test questions. It shows up periodically. Okay, a lot of the repeaters that we have talked about are FM repeaters. There's a digital mobile radio system or digital audio systems. One is DMR that Alan had mentioned earlier. The other is a competing manufacturer, has a D-Star direct digital smart technology amateur radio system. They're both digital systems. They're not compatible. If somebody's come up with something that I'm not aware of, but both send digitized voice signals over the air and can link these things into the internet. So the repeater uses the digital mode hotspot to connect the computer or smartphone to the internet. You can actually dial into some of these repeaters from the internet. And you have to program your call sign into the radio, and that gets sent digitally with each transmission. More on DMR, there's something called a talk group. You program your group ID into the radio to join. That acts as a kind of a tone squelch kind of a thing. We'll talk about tone squelches in a minute, but it only opens up the repeater if your radio ID matches the group ID that the repeater is programmed to join. You do that with a DMR code plug that contains the access information for the repeaters and the talk groups, and it is done by color. That's another test question. And I believe a color is actually programmed in as a number. So yeah, in the early days, they actually used physical plugs with different colors, and I think they just carry that forward by calling it a color with entry into the software.
It's considered digital cheating.
Not really. I mean, you're still physically talking, it's just digital, as opposed to having a computer talk to you.
Station equipment, you can have independent transmitters and receivers like on the top, or everything rolled into one, or the transceiver on the bottom. The basics are, again, the transmitter and receiver, transceiver, and an antenna to switch between a transmit and receive. So you use a common antenna for both transmitting and receiving. And push the talk button on the microphone or a line on an accessory jack. There's a key line to it. Power amplifier. Purpose of the power amplifier is to increase the RF output from a low power device like a handheld. If you're going to use this thing in a residential setting or in your car, you wanted more power than just the 2 or 3 watts. You take your handheld, put it into a power amplifier, and the power amplifier has got a transmit receive switch built into it. It's normally it's normally connected from the antenna to your receiver. When you transmit, senses power and it goes through the transmission zone.
Run this box down.
Okay. Single sideband CWFM switch sets the amplifier up for the appropriate mode. Receiver specifications. Well, most important are the sensitivity. The sensitivity is the ability of the receiver to detect a weak signal. And another important one is the ability to discriminate between adjacent channel or second or third adjacent channel signals, or to be selective, and that's called the selectivity specification of the receivers. And the addition of a preamplifier that's installed between the antenna and the receiver, and it tries to bring up the weak signals out of the noise. Key there is that the preamp signal generally is designed so that it has a very low noise characteristic in the amplifier itself. Okay. Some pieces that may show up on the test questions is the purpose of a mixer, convert signal from one frequency to another. The oscillator that generates a signal at a specific frequency. It's a single tone. And a modulator combines the speech with the signal out of the oscillator to get you to an RF carrier that's got the modulation and the carrier coming out. The modulation is the actual intelligence or payload that you're trying to recover, your speech. And often the modulator is actually implemented with the type of a mixer. And here we've got a typical transmit chain. The lower block has got the speech. The amplifier for driver amplifies the speech and sends that to one leg of the modulator. The RF oscillator has got the carrier that's going to come out, goes through a buffer amplifier and into the other leg of the modulator. Now driver and the buffer serve two purposes. Number one, it takes a very low level signal and it amplifies them up. The other thing it does is going into that modulator, if it's a mixer, it generates the top signal. But there's also a little bit of that signal gets fed back, and those buffer amplifiers provide reverse isolation so that you don't feed back one signal from the oscillator back into the speech amplifier, or speech amplifier back into the oscillator. Which you can see in the part in the upper right-hand side, the amplitude modulated signal, that the carrier frequency remains the same, just the amplitude of the transmitted signal. That's for AM. If it were FM, the space between the cycles would be changing, and the top hump would not be there. Dave, voice modes like single sideband and FM need the modulator. It combines the RF carrier and the audio speech signal to get the signal that's going to be amplified and out the antenna. Something called the transverter. This is used to operate on a frequency where the radio was not designed for. And typically you see transverters that'll convert a 28 megahertz signal up to the 220 band. Out of commercially available equipment, the 220 band is kind of unique, that there was, up until a few years ago, there just were not very many radios that were built to operate on 220.
What would be the purpose of that?
It takes it takes your transmitted signal and it converts it up to 220. And it takes the 220 signal coming back on the receive and converts it back down to your 28 megahertz signal, so that you can operate on 220 using equipment that wasn't designed to operate on 220. Okay. So the transverter is the device that takes the output of the 28 meg sideband exciter and gets it up to the 222. And it does the same on the receive.
Yeah, that's kind of the very top of the agenda.
Yeah, 3 to 30 is generally what's considered to HF. 30 to 300 is VHF. 300 to 3000 is UHF. That was the slide earlier on.
So a technician should be theoretically permitted to use the transverter?
Yeah, you could.
You have, yes, you have 28, you have 10 meter single sideband phone privileges.
Yeah, but even with the transverter, you're not really transmitting care on the agenda.
Okay, so you should see.
Since it's just going into the transverter is effectively figured out on this.
Yeah, now that being said, the transverter output, unlike your transceiver that would be connected to a 28 megahertz antenna, a transverter's got to be connected to a 220 megahertz antenna. That's where you're trying to operate. Just moving your frequency, your station's capability, giving you more spectrum capability. Most operation using FM and repeaters. CW and single sideband is also popular on VHF and UHF for weak signal transmissions. The device most useful is the multimode VHF transceiver. Handheld transceivers are HTs that have low power, 5 watts or less normally. And that limits the linear range between two stations on the ground. The device that increases the low power up to a high power we talked about earlier is the RF power amplifiers, RFP. Some common problems: overload, front end overload on the receiver at your end is a common problem. Distortion, feedback, interference, and things that can cause interference are, again, fundamental overload, harmonics, which are multiples of your fundamental, integer overload, so second harmonic, third harmonic. There is no first harmonic, that's your fundamental. And spurious emissions that may be caused by overload that get retransmitted back out.
Overload is the condition that causes.
Yeah. Yeah.
If too much power going to the receiver and cause the receiver circuit. It's like. It's almost too loud in your ear, just can't even hear it.
Right. The distortion is fairly at a gain.
Yeah, but overload is something that can actually. Not turning the gain up, you might have too much signal going first. Gains.
Can any of these in your transmission system can cause interference to radio or TV stations? If somebody tells you that your transmissions are causing interference, make sure that you're functioning properly first. Good first step. Take a look at your own TV or radio and under the same conditions and see if you can hear the same interference that you're getting complaint from. Telephone interference, this mostly happens with corded phones. They can be subject to interference. The most likely cause from a non-cordless phone is a transmitter that couples into the telephone lines themselves, either through overload or through some corrosion that may form on some of the connections on the telephone lines. Behaves as a diode and it rectifies your signal, and whoever's on the telephone can hear your speech. Acts just like a radio receiver, the old crystal set. Logical first step is to install an RF filter with the telephone. Broadcast interference caused by the receiver on the receiving end on its ability to reject strong out-of-band signals, often referred to as a fundamental overload. It doesn't have to be out of band, it can be off channel but within the same band. And drive your first amplifiers into causing distortion. Eliminated by installing a filter to block the amateur signal. Something that can happen in reverse. Reject filter there. Okay, if you're going to try to cure the interference, make sure that all the connections on the TV coax connectors are installed properly and tight, especially with the cable systems. Snap-on ferrite chokes around the transmission line might give you some relief there. And then the low pass, high pass filters and band reject filters. So.
Okay. I was thinking of the practice exam recently. I said, which of the following could be used if your distorted audio caused by RF current shield microphone? I guess the ferrite choke, but I saw like the low. I also had band pass, low pass filters there as options.
Yeah, usually if you've got RF energy coupling onto something that shouldn't be there, one of those snap-on chokes is really designed to kind of basically be a filter that block that.
I see. Okay.
It's kind of like you got water coming down, a wire, you put a sponge on it to absorb the water. It's the same kind of concept as that. So it's really that's a great place for action.
Okay, part 15 devices, which are unlicensed devices. If neighbors' devices causing interference, try to work with them to identify the offending device if it's causing interference to you, and then politely inform them of the rules that require them to stop using the device if it causes the interference. Check to make sure that your station meets all the standards of good amateur practice for your own emissions. And common problems: distorted or noisy audio. The transmitter might be slightly off frequency. Batteries might be running low, or you just might be in a bad location if you're mobile or portable. Noise in digital transmissions causes the bit error rates, which cause readability issues. And the bit error rate is the rate at which the errors are occurring. Garbled and distorted transmission could be caused by RF feedback or by over deviation which is also another way of saying overmodulation on FM. Back off on the microphone gain. High pitched whine in the receiver. Normally an alternator whine. Could be some of the other ancillary computer clocks that are found in a lot of the vehicles today. Okay, as far as measurements go, one handy thing to have around the shack is a multimeter or a digital multimeter. And these are some examples across the top. Traditional needle movement meter and digital reading multimeters. Multimeter is actually a 3-in-1 device, sometimes 4-in-1 if it includes frequency these days. But you have a voltmeter, an ohmmeter, and an ammeter all in one package. And depending on where the switch is selected, it generally selects the range and the whether it's a voltmeter, an ohmmeter, or an ammeter. DMM, short for digital multimeter. You see that a lot. Measuring voltage and resistance are common with tasks for the digital multimeter. To measure voltage, like in the center meter shows it placed in the circuit across in parallel with the load for the device to be measured. So you measure voltage in parallel with the circuit. If you're going to measure voltage, make sure that the leads are at least rated for the voltage that you intend to measure. So if you're going to measure 1,000 volts with meters that are insulated at 600 volts, you've got a problem. One other thing I want to add here is that this has happened to me twice. With digital multimeters, some of the stuff that's available on the commercial market today is not of the best quality. And if you take a look at the center, for instance, with the red test lead where it plugs into the meter, I've seen those meters open up where it doesn't make a very good connection. And if you're trying to measure voltage with an open circuit there, well, cross may be a hot circuit and the meter's going to indicate 0 voltage. So what I've done is made it a practice to always put it on the ohm scale first and touch the two test leads together to make sure that your meter is actually telling you what you think it should be telling you. Make sure that you have a deflection or a 0 reading on the ohm scale.
But be sure to take it off of ohms before you put it on the voltage. Yes.
Exactly. I was going there. I was going there, John. Yeah, you want to make sure that you don't try to measure a voltage or a current with the meter set for resistance measurements. Measure the current, a little bit different setup. You set the meter to be in series with your source and load, and you measure the current being delivered to the load in series with the meter. And resistance measurements. Okay, the ohm meter setting is used for measure resistance. Make sure that the circuit's not powered. And the normal procedure for this is to touch the two leads together, zeroize the meter with an adjustment if it's available, so that the meter is reading 0 ohms, and then make the measurement across the device that you're going to measure. One other tip, if you're going to measure this in a circuit with a printed circuit board, you want to lift one end of that device under measurement for resistance, because you don't know what other traces in there may be giving you a parallel sneak path, and parallel resistances divide. So you'd be getting the wrong answer if you're looking for a quality. Yeah.
If you inadvertently have it ohms, test for voltage with that private.
Probably.
Yes.
Probably.
That's the most common way to data.
Yeah. Best way to get it to a recycling center.
There's a big private regular flea market that's really cheap that doesn't work right. Problems. And sometimes it's an internal fuse that can be replaced.
And to your point, the next line on the slide, right there. And when you measure the resistance, you may see the meter kick up on initial contact and then slowly increases. That means the capacitor or a circuit contains a large capacitor. And again, place the leads across the device. Okay, some soldering. Soldering's a skill that you can acquire. Takes some practice sometimes. Rosin core solder is best for the radio. Do not use the acid core solder that the plumbers use. That's not the best thing to be using. The indication of a good solder joint, they're real easy to mess up. And the reason they normally mess up is because you don't have enough heat applied to the joint as you solder, or you move the connection before it's thoroughly cooled. The top picture gives you the sign of a good joint. You have smooth and shiny connections. The dull or grainy connections in the bottom two are an indication of a cold solder joint, where you didn't have enough heat or the wire was moved during the cooling process. And really, what I've done is actually gotten a soldering iron in my hand, put a tin of solder on the hot iron, take it on a sponge, that gets all the dirt off, and the flux in the solder will find in the sponge. Tin it again, and then go make the connection. And apply the soldering iron to the connection before you put the solder onto it, because you want to make sure that the material that you're soldering is hot enough to conduct the solder. Some operating procedures. One definition is definition of simplex and duplex operation. Duplex is communications between two devices on different channels, different RF channels, different frequencies, where the radio on the left would transmit to the radio on the right on one, and the radio on the right transmits back to the radio on the left on a different channel. It's known as duplex operation. And that's really what the repeaters use on their two links, uplink and downlink, transmitting and receiving on two different frequencies. Simplex is transmitting on the same frequency, or one radio transmits, the other one listens on that frequency, and they reuse that frequency to go in the opposite direction. Simplex and duplex. And within the band plans, there are dedicated simplex frequencies to allow nearby stations to communicate without the use of a repeater. So if you're communicating from one side of the parking lot to the other with somebody, you use a simplex channel. If you want to throw within a mile or two, if you don't have radio line of sight, go to the repeater. Okay. Dedicated simplex. National simplex frequencies on 440 and 70 or the 70 meter band was 446.0 on the 70 centimeter band and 146.52 on 2 meters. There are some others that are on, but those are common. Some of the common controls that you find on the transceivers at VHF, UHF is the carrier squelch, that again mutes the noise coming out of the speaker if you don't have an RF signal going in. Microphone gain, it changes the amplitude of the modulating signal. Determines the amount of frequency deviation of the carrier that your speech will make. If the deviation is increased, the signal occupies more bandwidth, and without changing the volume control at the receiver, it sounds louder at the receiver. That's the effect of increasing the deviation. FM operation. Okay, the repeaters listen on the input frequency, and they simultaneously retransmit that signal on the output frequency. So you see the vehicle there is transmitting on 456, 775, and it's listening on the vehicle transmits on 456, 775 to the repeater. It retransmits that signal on 451.775. So it has a, what would be referred to as a negative split, or the split direction is negative, and it's by 5 megahertz. Okay, so the output frequency is 5 megahertz below the input frequency. Make sense? Question?
Yeah, it's not, it's the perspective of repeater, of the perspective of the repeaters.
Yeah, it's frequency.
Okay, so your radio is set to transmit on a receiver input or a repeater input, and your radio is set to receive on the repeater output. And do your programming.
You can't feedback. You transmit, then you can see.
Yeah, but that's why there's.
That's why they're split in frequency.
So that the Repeater itself, listen on one frequency, the transmit on another, so it doesn't hear itself, it's not listening to that.
Oh, I thought you said it's because it's receiving on the output of the repeater, then it would just come right back around to it.
No, your vehicle is receiving on the output of the repeater.
Yes, sir. You're transmitting on one frequency, Peter retransmitting that on a different frequency, but while you're transmitting, you won't hear it. Your transmitter will only work and transmit or receive. The repeater does both simultaneously. The radio you're doing, so you don't want to get.
Yeah, I'm guessing the buzz radio is told this way.
Right.
Right.
Your radio, they have covered.
Design a radio or compete with software radio that comes from transmitters.
Yeah, the difference is that the repeater operates in what's called full duplex. And it's operating on two different frequencies simultaneously. Your radio is operating at.
Okay.
Transmitting in one and the other.
All right. Again, the difference between the input and output is referred to as the split. And most techs start with a VHF, UHF, FM transceiver. So stations that automatically retransmit signals are repeaters, auxiliary stations, and space stations. Each one of those has a definition. I described a voting system repeater earlier with multiple receivers. The link between the outlying receiver and the repeater control point where that link would go to, it would be an example of an auxiliary station. Okay, that's an FCC definition. Space station, I think, is anything above 50 miles.
260 miles.
Yeah.
So it's
Oh,
usually satellites.
usually a satellite. Common splits again, 600 kilohertz for 2 meters, 5 megahertz for 70 centimeters. And there are linked repeaters where signals received from one repeater get linked either by internet or by another auxiliary station loop to another repeater. And all of the signals get your signal would get transmitted by all of the repeaters that are linked in that network. There's at least one linked network that I'm aware of. Here in New Jersey, there's one in Pennsylvania.
Very big one out of the west coast of California, where once you get into that network, your signal will be in San Francisco and Northern California, and you're linked to repeaters all over that. Huge number of people here.
All those individual repeaters in that network have different offsets around.
Yeah, they're operate with the frequencies because oftentimes, like I said, this repeater will take the audio and then bring that over to the repeater that's out on its frequencies. And they go all the operating frequencies, and you just have to move one.
Yeah, there is one common frequency that's used by all other repeaters that we haven't talked about yet, and that's called the tone squelch, the PL tone. Sometime that's coming. Right now. Okay, CTCSS, carrier tone, continuous tone coded squelch system. These are subaudible tones. There are a list of about 50 of them that are audio tones that are sent along with your voice on the same channel, but at a very low level. So they're very difficult to hear. Some are below the edge of human hearing. It's also called private line or PL. That was a trade name from Motorola. You hear somebody refer to CG or channel guard. That was a General Electric two-way radio. And they're all the same thing. RCA used quiet channel. There's also digital coded squelch. I think we're going to get to in just a second, which is a digital version of that. Some of the reasons why you can't hear the repeater, or why you can hear the repeater but can't talk to it. Maybe you've got the improper transceiver offset, the wrong direction going, where you should have a plus 600 kilohertz signal on 2 meters, and you've actually programmed your radio for a minus 600. Done that. The repeater requires the tone squelch for access, and you didn't plug in the right tone squelch frequency. You may also be hearing the repeater because your receiver doesn't have a tone squelch plugged in, but your receiver doesn't know not to respond to that, so it's responding to the level that it hears. So you can hear the repeater without having to plug in the tone squelch frequency into your receiver.
So the thing is, the repeater's not rebroadcasting.
Right, yeah, if the repeater has a CTSS enabled, if you're not transmitting that thing on your audio, it's just gonna ignore you, essentially not open up its receiver to allow you.
The difference between them, there's two different formats, but the
The vast majority of the repeaters in the area are using CTCSS. There are some repeaters that use this digital place. That's often something that you see on more like when or many amateur.
Yeah. Okay. Yeah, and the other thing is that some repeaters will only have the tone coded squelch activated on the receive side. They don't transmit the same squelch frequency back out.
it's not just nine broadcasting.
Yeah, so
Right, because they have something like this.
back before they went to the digital trunk radios, they would use things like TCF to allow certain transmitters.
Okay.
Now, the trunk radio system still does the same thing.
Again, if the repeater isn't strong enough to open your squelch, you might try listening on the input. Again, that's a question that I've seen on the recent tests. If your signal's breaking up, you may be over modulating or over deviating by talking too loudly or having the mic gain set too high. So if you've got a volume control, back it down. If you take your mic, or if you're talking too loudly, physically back the mic away from it. Stop yelling at the radio. How to strike up a conversation. Okay, well, like I had mentioned before, CQ isn't really used. You just want to drop your call sign and mention what frequency you're listening on, the last two digits, like W2AEW listening 67. Tells everybody.
Something that's commonly used on HF. It's basically a general call out. Hearing. Repeaters, we generally don't do that.
To call somebody, if you hear somebody else call up, you say their call sign, identify with your call sign. Okay, for HF operations, CQ again. Calling all station. There's an example of how to speak it. If you're doing Morse code, you would type out the characters C and then Q. Always listen first and ask if the frequency is in use. Nobody responds. Make sure your frequency is parked where you think it is, and call CQ. They respond to the CQ, transmit the other station's call sign, followed by yours. Station ID, you always want to properly identify when you're transmitting, even when you're testing. The requirement is to identify at least every 10 minutes while you're operating and at the end of your operation. Now, text can operate CW on 80, 40, 15, 10 meters in HF. Okay. They use Q signals. And this is a carryover. You'll hear the word spoken as QRM, indicates interference. QSY indicates your changing frequency. QSL, which is what those cards were called that Alan mentioned earlier. The QSL means acknowledge with receipt. Again, it's a holdover from the old Morse code days. One thing that you want to be careful of, if you're going to operate on 10 meters and you're doing CW and then you decide you want to try FT8, it's legitimate for you to transmit on FT8. I've been seeing a lot of cases where technician class licensees are transmitting on 80, 40, 20, and 15 meters. You don't have FT8 privileges. Only CW. Okay, so the digital modes for text are limited to 10 meters. So just be careful of that. Okay. Okay, we've already discussed a lot of that stuff. The band plans, they're a voluntary guideline for different modes. Here's an example of a band plan. Although the first 100 kilohertz in 2 meter and 6 meters is not voluntary, that's actually mandatory. That's by regulation. The rest of these splits where you have repeater inputs located in the 145, 146, and 147 portions of the band, those are generally voluntary.
Gentlemen's agreement.
Yeah. Although you see some deviations to that, and also you see non-standard splits. The organization that hosts this session operates a repeater with a 1 megahertz split on 146.46. I guess it's 146.76. It's the other side of that. So they are around. Amateurs are required to use the minimum power necessary to carry out the communications. You're allowed 1,500 watts on VHF and above, but as a tech, you're limited to 200 watts peak envelope power on HF in the 10 meter band. No, you
on
can-
10 meters. CW on the lower bands.
200 watts in all these. Yeah.
Yeah,
Starting at.
yeah, but that's the rule, is to use the minimum power necessary. There are people that go down and look the whole time regardless. You know, for me, my challenge is how low power can I go?
Typically, the Wi-Fi and everything is houses.
Right?
Yeah, it's the same.
Yeah, but most of the HF rates that you get are 100 watt rates. It's like power. It's the VHF and UHF. Anything to get above the 200 watts. No transceiver.
Yeah. Okay, so two stations that want to use the same frequency should negotiate between themselves about who was there first. Nobody owns any frequencies. More guidelines. The ICAO phonetic alphabet, it's the International Phonetic Alphabet. It's down there in the lower right. You want to stay clean. If you get a report you're causing splatter interference, check your the transmitter for proper operation. Either right on the frequency that you think it is, or make sure that you're not putting out anything on a frequency that you were not intending to put out on through a spurious emission. And if you unintentionally cause interference, identify yourself and move along. And the use of the phonetic alphabet's encouraged by the FCC.
And really to use this, people will sometimes put their own mnemonics on things. And it's fine to kind of joke around with that, but for the most part, you're talking to people who English is not their native language. They may not understand the other words, but they'll understand these words that they substitute.
Yes. Okay. Well, hams are uniquely qualified to help in emergency and non-emergency situations, a variety of them, helping to keep things organized at special events. But the FCC rules still apply to use an amateur radio for public service, public safety operations. In the event of safety of human life, all the regulations go out, and you can use any means necessary to get the message through. And there's human life or property damage associated with public safety. Okay, there are two organizations. One is the Civil Defense Organization. The other is primarily the ARRL that gets together amateurs to support public safety and emergency communications. The RACES is the Civil Defense Sanctioned Organization, certified by the Civil Defense Agency. And you're able to use amateur radio frequencies during drills, exercises, and emergencies. It's activated by the local, county, and state jurisdictions, and the only amateur radio operators are authorized to transmit that are those that are in civil defense when the president declares an emergency under the War Act. Yeah, I think so. But that's the RACES organization under FCC Part 97, certified by the civil defense folks for emergency management. And the other is ARES, which is the Amateur Radio Emergency Service, and that's a group of licensed amateurs who voluntarily have registered their qualifications and equipment capabilities to be pressed in the duty for public service. And it's common for service in these things for the amateur operators to form a network or a net. It's orchestrated by a net control station. NCS messages are passed during these are called traffic. And after checking in, you with a net control station, you remain on frequency until you're called. Network operation procedures. For message traffic handling, there are both informal and formal messages. It's most important to pass messages exactly as they're written or spoken as you receive them. You always want to use the proper phonetic alphabet when handling message traffic. Four parts of the message are the message preamble, the address, text, and the signature. The preamble is used to track the message as it passes through the amateur traffic handling system. Preamble checks the number of the words or word equivalents in the text of the message, and it checks them. The address is the name of the addressee or the recipient. The text is the body of the message, and the signature identifies the originator of the message.
Just to be sure that something didn't get lost. It's a way of saying it.
It's a bookkeeping thing.
Yeah, saying if this message contains 50 words, if somebody copies down the message and 48 words, it's.
Yeah. Okay, all communications are through net control. I like to think of it as a star where you have the net control in the center and all the outlying stations around them back and forth to the net control. Only transmit when directed by the net control station. There are several nets that are in this local area. One on the N2RE repeater meets every Tuesday at 9 o'clock. And there's one that meets daily on 146.67 DVRA PepperNet. I think they're at 10 o'clock at night.
Be social.
Yeah.
For the purpose of- that's social.
Yes. If you really have a problem, really need to get through in an emergency situation, just drop the words priority or emergency by your call sign and get the net controller's attention. We'll get you some response. Amateur satellites, repeaters in space. It's got the uplink and downlink frequencies. They're often on different bands, where in terrestrial repeaters, we have 600 kilohertz and 5 megahertz splits. These folks go by completely different bands, where UHF is commonly the uplink, and VHF for 2 meters is the downlink satellite back there. Need license privileges to transmit on the uplink frequency. Your technician class license covers that. You want to be sure that you use the minimum necessary power to close that link on the uplink. Part of the reason for that is to conserve the power on the satellite, because he's going to respond to high level signals. Most are FM. Some operate CW, single sideband and data modes. And you can talk across the oceans. Okay, satellite beacon, that's a transmission in space that gives you some information about the satellite. Usually it's health and status, and anybody can receive the telemetry there. Common problems, Doppler shift. If the satellite is moving towards you at some speed, you're going to see a change in frequency. And if it's moving towards you, it's going to be higher in frequency. If it's moving away from you, it's going to be lower in frequency. And you see some spin fading that's caused by the rotation of the satellite's antenna. Don't use too much power, because you might block the access tower. And your signal strength on a downlink should be about the same as the beacon. FM packets commonly used to send to and from digital messages to the satellite. Some are stored in forwards, others are forward in real time. Satellite tracking programs. There are maps that show real-time position over the Earth. Azimuth, elevation, start, max satellite altitude, end of pass are typical products of the program. And the program takes the Keplerian elements as inputs.
Like satellites, GPS. Satellites being stationary satellites. Sky. These are low satellites, and space station. It's going to go around the Earth, so you've got to look at these things to see when you're going to pass, that you can actually operate the satellite. You don't have 3 minutes of visibility of that stuff.
Yeah, they're typically low power, low orbiting satellites. There's actually one case where the shuttle got a spacesuit and put a 2 meter handheld configured as a repeater. And it was a suit sat repeater for a little bit.
Out of the satellite, eventually, re-entered the atmosphere, but for a while, it was astronauts.
Okay. International Space Station, any tech class can contact the space station on 450 or 2 meters. And space station's a low orbiting satellite. Okay, some fun activities. Contesting. You can make contacts in a specific period of time, see how many stations you can work. And you send only the minimum amount of information required by the contest, which is normally an ID, a signal strength, or signal report, and contact number. There are others, different contests have different requirements. But be mindful of others that are trying to participate in the contest too, because the bands can get pretty crowded. And UHF contests often use the grid locators, which you see on the right-hand side. And the grid coordinate system used here is the Maidenhead grid coordinate system. Consists of major squares of 2 letters followed by 2 numbers, which are 1 degree in latitude by 2 degrees in longitude. You see northern New Jersey is FN20, and for their grid location. Southern New Jersey is something else that I can't quite read here in this graph. FM29, I believe. That's Mike 29. Okay, and there are some cases where even a finer resolution of additional 2 letters, 2 numbers can be added to these. 4 is generally the number. More activities, special event call signs. N2RE recently celebrated yesterday with 2 days ago with Pi Day, right? 14th. As November 3P. How many contacts did you make, John?
I made 94. I haven't seen the total count for everybody that was using the special event call.
Very good. But you came up with a special call sign and of November 3 Papa?
Yeah. Yeah, we use that one every year. I know Dawn, our president, did 100 and some contacts, and like I said, of the ones I know, were at least between 300 and 400 contacts.
Wow. Very good. Very good. And also the local, other local club, the VVRA, normally in December celebrates the Battle of Trenton with Whiskey 2 Tango and Whiskey 2 Papa for the Battle of Princeton during that last week in December. Okay, more fun direction finding. Fox hunting, find a hidden transmitter. They come up for, I don't know, maybe a minute every 5 minutes or some block of time. Go try to find the hidden transmitter. It adds to your skills in interference detection and jammer hunting. Usually use a directional antenna, but I've seen people use Doppler direction finding systems that are mounted to the top of their car.
One Fox hunting story years ago. About that had a box hunting and a little transmitter in somewhere, and people looking for it. But at the end of the day, nobody ever found it. But the interesting thing was that the transmitter was actually sending its location in Morse code. But everybody was just listening for the signal, but didn't bother to decode the Morse code. If they had done that, they would have said, "Oh, the gas station in the garbage." Nobody did.
And internet connections, mixing internet with the amateur radio. A lot of the internet repeater linking project uses the voice over internet protocol. You can look in the repeater directory to find a list of the active nodes as well as some online lists for the local systems. And the dual tone multi-frequency or touch tone through the keypad on the radio is used as a dial-up node to get into some of those. Okay, Echo Link is where you can get in through your computer back through the internet. You have to register your call sign with the Echo Link folks to provide proof of license, but it's you can go worldwide. Some of the repeater systems that are linked up by this, you can use a repeater without using the radio by your Gateway is the name of the station that links other stations via the internet. Okay, some of the rules and regulations that are applicable, which you're likely to see at least one test question related to rules and regulations. The amateur radio serves the purpose. One of the purposes is to advance the skills of the technical communication phase of the art of radio. Actually seen that verbiage. In this country, we're regulated by the FCC and enforced by the FCC. Part 97 of the FCC rules and regulations apply to the amateur radio service. And the definition of an amateur radio station is given down there at the bottom. Carrying on amateur radio communications, you may see that verbiage in there as well. If you're really wondering, it's under Title 47 of the Code of Federal Regulations, where 97 rides. Space station, there's the definition, 50 kilometers above the Earth. Beacon, amateur radio station transmitting communications for the purposes of observing propagation-related things. Volunteer frequency coordinator is a recommendation generated by someone that's selected by the amateur radio operators in the local or region area. Tries to coordinate repeater usage so that there isn't any co-channel interference between the two. Okay. Simultaneously, a repeater will transmit the signal on amateur station to a different channel. Auxiliary station, one transmits over the air from a remote receive site to a repeater for retransmission. Interference, harmful interference, stuff that really messes things up. It's never permitted. And intentional interference will take your license, maybe issue you a fine. I've seen 5-digit fines proposed, and even prison time if you're interfering with the wrong people. ITU, the International Telecommunications Union, they're like the FCC participates in this organization. This is an international organization that's chartered by the United Nations. They're headquartered in Geneva, Switzerland. They have a field office in the UN building in New York. I've actually had some dealings with the local office. They're very, very easy to deal with. Good folks for some of the issues. They publish a lot of technical recommendations and specifications if you're so interested. Yes, they're right. 3 ITU regulations. North America happens to be in Region 2, ITU Region 2, which is the ITU deals with the worldwide amateur radio issues. The FCC deals with US only, but within the ITU frame. Again, frequency mode allocations, the 10-meter details that show that you can use CW, teletype, or data, the FT8 types of transmissions on 10 meters only on the lower bands, on 80, 40, and 15, Morse code only, CW only. Above 50 megahertz, you have all amateur privileges, but your power and modes of operation are restricted below 50 megahertz. Questions on frequency band. Another use of the circle for the equation to get wavelength, frequency, and propagation velocity all in one, which is a 300 number, 3 times 10 to the 8th meters per second. 52525 within the 6-meter band. Single sideband is permitted in portions of all the amateur bands above 50 megahertz. And the 2-meter band is what you're using when your station is transmitting on 146.52, the simplex channel.
Okay, so just random bits and pieces that may appear in questions. All of these functions.
The 443.35 of the 70 centimeter band. 1296, the 23 centimeter band for And the 220 band, the 1.25 meter band, transmitting on 223.5, and something to note in that footnote in italics down the bottom, that you may see on the test, is that 219 to 220 is reserved for a digital messaging format, similar to the first 100 kilohertz in 2 meters for CW. Techs have HF phone and teletype privileges on 10 meters only. So I'll try to operate on one of the other bands with teletype or FT8. And your power is limited to 200 watts in the assigned portion of HF, 1500 watts above 30 megahertz. Primary and secondary users. Well, we share the spectrum with a lot of other services. Some of them are primary. Sometimes we're the primary users, like on the 450 band at 70 centimeters. Sometimes we're the secondary users, where we share 23 megahertz with some radio location services. And if you're cannot cause harmful interference to primary users. If you find that you've got an interference issue on 23 centimeters, you've got to stop transmitting and take action. Subbands, again, the first 100 kilohertz in 6 and first 100 kilohertz in 2 meters still reserved for CW only. Mode restricted subbands, we talked about the 220 digital message forming. Frequency selection, you want to make sure that you don't operate right at the edge of the band, because what can happen is your radio will be tuned to 100 kilohertz inside. You start talking, and you've got 1500 hertz outside if you're on voice outside the band. So just be wary of the band edge. And also be mindful when you're operating in 10 meters of the frequency limits. If somebody suggests you transfer QSY, change frequency, to another frequency within that 10 meter band, you may not have operating privileges for voice, but he does. Just remember where your limits are.
Joe,
Sorry.
the other night, just for fun, I was copying the ARRL bulletins in CW just for practice. And one of the bulletins had a summary of the official observer violations that had been issued over the previous month. And the leading one was people, at least I believe it was the first, it was either the first or the second, was people right at the band edge that were spilling into outside of where they were allowed.
Yeah, very good. Very good.
Very common mistake.
Yeah. Yeah, thanks. Reasons why, again, so modulation sidebands don't go over the spill over the edge, and you want to compensate for or give some allowance for transmitter frequency drift, because your transmitters will drift over over temperature changes and over time changes. Licensing and operating, your license is actually 2 in 1, an operator license and a primary station license. Be aware of that. Call signs, you're going to be issued a call sign. Technicians are usually 2x3s, which are described there on the slide. 1 or 2 letters, a number, and then 3 additional letters. Only 1 operator primary station license grant per person. Vanity's call signs are available to any licensed amateur. They have to match the format for your class of license. Technician general and extra class licensors are the only new licenses that are being issued, available. There are still some novices around. There are still some advanced class licenses that are around. I think there are even some conditional class licenses, but none of those are given. No new issues. Special events call sign, we had talked about those. Whiskey 8 Charlie is an example of one. Clubs. Want to make sure if you're going to form a club, you can get a license. And this is a test question. You have to.
Sorry.
I'm sorry.
You said it 1 by 1. What's the C at the end of the W?
Whiskey 8 Charlie, that's a 1x1.
It's a one by one special event also.
Special event.
An event or something where those numbers that letter meant something.
Yeah,
Oh.
one letter, one number. Yeah, one letter, a number, and a letter. If you're gonna be a club, you have to have at least 4 members to get a license. That I've seen show up. Records and operating. Logging individual stations is no longer required, but you have to keep your mailing address current, and they want a current email address these days. One example of a good idea to keep around is your RF radiation survey. Make sure that you've done that. In case somebody comes knocking at your door, you can reach into the filing cabinet and pull out a piece of paper. Okay. If correspondence is returned, the FCC will cancel your license. So when can you operate? Well, as soon as your name and license call sign appears in the FCC database in the computer. It's that's the proof of a license grant. License is good for 10 years and it's renewable. Renewable grace period is 10 years. You have to renew it within 2 years. You have to renew it within 2 years of the expiration date. You cannot transmit until the renewal shows you back in the database. You're going to operate outside the U.S. Some countries have reciprocal agreements, like Germany. You want to check the local restrictions. International waters on any vessel or that's registered or documented in the U.S. You got to be very careful on this one because a lot of the cruise ships are registered somewhere else. Not legit to use an amateur radio. In fact, some cruise lines have specific prohibitions about using amateur radio while they're under oil.
Even if they are about pretending to British US, you can always check with the cruise line.
Yeah. And I've actually operated maritime mobile and aeronautical mobile with permission of the pilot commander from the master of the vessel. But again, it's got to be U.S. flagged or U.S. registered aircraft. Authorized and prohibited. Common sense kinds of things. Unpublished codes or ciphers are not permitted, except when transmitting control signals to a space station or a radio controlled model. There are some radio controlled modelers that use high power transmitters to control their model at long distances. They're hams, so they're under the same ID restrictions we are for voice comms every 10 minutes and at the end of the transmission for ID. But those are the only guys that are allowed to use unpublished codes or ciphers.
Break down for music, retransmission, space station.
That's because, yeah, that's there because oftentimes, talk to somebody on the space station, they may have music playing in the background. And it just might be incidental to the communication, you just happen to hear it. So they just put that rule in there so that we don't tell the astronauts to put this call. But there are enough restrictions on the supply.
Okay. Something else that's restricted is communications with any country whose administration has notified the ITU that it objects to such communications. You cannot use your amateur enterprise to make money.
You're using a cell phone that communicates with satellites that you use out of this ship.
Yeah, that's covered under.
That's a different part. That's not part.
Like that. And it's they're pretty well controlled in terms of frequencies that operates on, the modes it operates on, the amount of power.
Yeah, and it's not regulated.
Right.
Yeah, it's not regulated under Part 97. Okay, except compensation for classroom compensation or occasional notification of equipment for sale.
It's pure instructing some things on them, radio, venturing into radio from the classroom as part of the teaching class. You're getting paid as a teacher. You're not really getting paid. That's an exception.
No broadcasting, and there's the definitions of intended reception by the general public, except when Communications relate to the immediate safety of human life. Again, everything goes out the door. Or code practice. Bulletins, ARRL bulletins. It is allowed. Communications incidental to purposes of amateur service. General remarks, kinds of things. Brief transmissions for making adjustments to the equipment. Control operators. Station always has to have a control operator. Never operated without one. And who's a control operator? Well, person for whom an amateur radio primary station license is granted, appears in the FCC database and is authorized or was authorized by the Alien Reciprocal Operation. And it's usually the station licensee. Licensee has got to be of the class for the privileges that you're operating. The technician cannot be a control operator for something in the extra class part of the band. Control point only required for transmitting, designated by the station licensee. Both control operator and the station licensee are responsible for the proper operation. But the control operator is responsible for the operation of the repeater. And the control point is the location at which the control operator functions as a control operator. You can have local control, remote control, where you're operating a station over the internet, and you can have automatic control. Well, the automatic control is the only permissible operation where the control operator can be at a point other than the station being controlled. Station identification every 10 minutes using English or CW. Phonetic alphabets encouraged. Exceptions when you're transmitting signals to a model aircraft. Stand correct.
Is that just the English, is that FCC or is that also ITU?
It's FCC, I believe.
It's FCC.
Yeah, it's part of the part 97. Tactical call sign for race operators, but you still have to use your legal ID every 10 minutes. More of identifications. These are the numbers where you're, or a map of the US, how the numbers were originally assigned. You're going to get a 2 call sign if you live in New Jersey, or a 3 call sign if you live over in Pennsylvania in the 3rd district.
It used to be that if you moved from one district to another, you had to get a new call sign, so that call sign match. They dropped that rule. So now you can have, like, I can move from New Jersey to California, I would have to change my call to 6 call sign. So it's, this makes it more confusing, you don't know where people are. But sometimes you can help them out and say, well, if I'm traveling or something like that, if I'm driving in Georgia or something, I might say, let me tweak that.
Okay, third party communications. Those are communications that are on behalf of somebody else, like you're going to pass a message to your cousin in another country. Be a little bit careful, make sure that third party agreements are in effect between the US and that other country. And they're authorized by the FCC with any station that's whose government permits third party traffic exchange with us. Station records. Good to see you, Alan. Okay, that's all I have. Anybody have any questions?
So that's brief review of all the material. Say it's about 2 o'clock, right? Let's see.
Just about.
So about 5 minutes after 2. Why don't we take we want to take a 10-minute break? What we'll do is we'll come back. Any questions immediately after that, we'll do that. If not, we'll jump into some practice tests. We'll run through a couple of those just kind of all together and see how well everybody does. Some of the VE team is showing up here, so we'll be ready to start the testing session at about 3:30. So we've got some time to go some questions and practice. So, thanks. So why don't we take a break till about 1/4 after? We'll get back.
Sorry, I didn't mean to run so long. I screwed that RC.
I didn't
I thought,
know.
I thought you had, I thought you had to identify,
Well, I know they typically identify with a flag on the antenna.
but they used to have a Morse code key that they had to identify.
Oh, really?
CW. Yeah,
Okay.
it used to be right on the boxes.
Oh, wow.
I didn't realize that changed.
Okay, yeah. I didn't even-
I have a question for you guys.
Yes, sir.
Do you recognize this device?
The 15 Delta Squad exam.
Okay, that's your one.
I'm in the cash up.
Yeah, it's like, I know, I was contacted by.
No.
I picked it up somewhere and I have no idea what it
Cash
is.
Got
in
it,
the
got
coast.
it.
Most guys, I come back at the end of the will, like us.
Okay. I don't know the answer.
That's good. That's why you referred me to Walter. Understood. Oh, I see.
Are you licensed? No, okay. Okay, have you studied it all? Yes. Okay.
So
Yeah,
did we successfully connect to the internet? Because I see that,
Yeah. Well, I mean, Zoom wouldn't be on if we weren't, so.
they even, when they do the
I saw that.
I'm sorry? Yes, yeah, well, I told them before or after, come back and do that.
Select save.
Oh,
I'm sorry?
Select some big.
I think it's a volunteer. There's an organization, it's one of the other members, it's,
Yeah, like technicians, a lot of regulations. So much.
The one that potentially was just so there's as regional, so amateur operators in local regional areas, or the local chapter of the Office of National Council. I get He's the one that had trouble with all like the equations and everything, the frequency, I got that, and I got like.
yeah, something about that. Sure.
One of our big bands is such, approximate all the areas. Yeah, so like. Yeah, well, from 10 to 1 meters. So the area by.
Got
And so, yeah, sure. So it's just, I know for other sources of each other. So. Like multi-meters for the states, around 28 megahertz. So 20 meters is twice the wavelength, so it's half of the production, so you have 14.
I passed this a few times.
The
Full.
the
But then when I started getting, I got lucky because it focused more on the science, but sometimes it'll focus more on the actual, specific rules about frequency bands.
Yeah, there's basically the quarters of questions that involves.
Yeah.
They're broken down into categories, the same categories that we have. But then it'll be like three.
We're all very grateful that they slap that out, because otherwise they have.
So the interesting thing to see too, is all the that's what they were here, like, here. These are the exact wording.
Yeah.
The answer to the exact wording, so you want.
Yeah.
So if you, no, I remember that question.
Yeah.
Really question of what the answer.
hi, I walked right past them.
Yeah, there's a lot of, use, get on the mail.
Okay.
Yeah.
Like.
Okay, very good. They went and started about quarter anyway.
So periodic, see guys.
No, quarter round is two.
So.
You know, they're moving ahead of their expectations.
Right. I was telling him I have a background in.
Okay.
Like, just doing all that.
Well, that's why I mentioned earlier on, I'm a double C, and the general performance test and the extra test, so I can easier.
That's funny.
It's less almost a branch memorization. So actually, we're technician. There is a, cost you can make you outlet, you have to look at it. And it's more effective, but you're more likely to try it. You pass that one, you'll think you want to take that. You take that one, shoot.
Having never operated radio.
I mean, never operated radio, what kind of internship? I've seen people do it. I've seen people go up to the extra meetings.
I looked at the, had the flash resistor.
Yes.
But none of the answers, the answers
I registered all my guys with TCF, but I guess you didn't register
Well,
yourself.
I might have a tag over there. and I-
No, at least Lenny, Al's wife, couldn't find one for you.
So what's the purpose of? Don't answer it once, or it should be. But most people will say, that wasn't.
We'll see you back later.
It's like, your bias is in the matter. Yeah, it does, but that's not.
Does that, but that's not why.
Yeah, that's not one.
Well, I don't know, I think it was the extra class that I took. And, you know, because I didn't listen back to public, but I'm very confident in everything. And that's the, oh, just fast. I forgot, that's what the last one, so the last 8 questions, I didn't pass. Sounds like it's fast. No, I think I'm good. Yes, sir. Unless we've got water down in that room down there.
Oh.
Started.
That's not our-
That's not all the water.
I've never seen anybody.
So this is a, because if you guys are interested in all this, is one of the local clubs is having those. So.
Yeah.
Plus,
Yeah, people selling beer, parts. And then all this stuff now.
Nice.
That's one of the motions.
Tailgate, like that.
Yeah, it's.
There were kegs and barbecues. Rock that's it.
Not quite that.
We did get his,
He was up here.
So you did get connected to Zoom?
Yes, we did.
Okay,
And it didn't ask for the.
I'm surprised, maybe because I had already authenticated myself
Okay.
on every device I own after
Yeah.
I changed the password.
Yeah, so yeah, like I got in and it's like, we're in, it's okay, nothing about the.
Yeah, I'm really surprised. Okay, that's great. I was worried that you had run into some drastic problem or something since I didn't.
Yeah,
hear
we
from you.
printed out your instructions all right here just to be sure, so, but.
Okay.
So, and it still says we're recording, so.
Has
we're
your,
screen
has your
sharing, so.
crowd, pretty much
We've gone up or down.
sustained?
Yeah, we probably had, you know, a solid 8 or 9 the whole time for the most part, so. A couple.
And are most of them planning to take the test
It
then?
seems that way.
Yeah, okay. Because Walt emailed me and was wondering how many exam sets he was gonna need to bring.
Okay.
And he had, I think, around 30 printed out. I
I
told him
don't
that
think-
would be fine.
I think it'll be fine, so we probably have, you know, probably have 7 or 8 here.
And then he
and
always
then,
gets
yeah,
some
other
just
people
for the
coming,
test.
yeah.
Yeah, I got one.
Folks, it sound like they might try to do general or something after that. So.
Yeah, I got some emails from people that were gonna come just for the test, so
Okay.
let's see.
I'm probably not gonna stick around for the testing session.
That's
so,
fine.
Yeah, so I got some family up in North Carolina.
Yeah, we appreciate you doing this each year.
No, that's fun.
Yeah.
We've had a pretty good track record, so.
Yeah.
ARL is converted.
In Newington, Connecticut, just outside of Milford. Right. Of course, there's like a stations there. Or. Good, but it's not good, but
Yeah.
you can go and you can actually operate the stations there, that station there. Okay. But you can, talk to the guys in the lab. Right, 2:15, let's get started with some progress tests. So we'll do these together. And we'll kind of get a vote of what everybody thinks the right answer is, and we'll see who's right, who's not. Okay, keep your own score type of thing, okay? So, all right, so question number 1. How is squelch adjusted so that a weak FM signal can be heard? Do you turn up the audio level till it overcomes the squelch? Do you set the squelch threshold so that the receiver output audio is on all the time? Enable squelch enhancement or turn on anti-squelch? What do we think? Who says A? How about B? Got a couple of Bs, C,
Session starts.
all right. So I think we agree it's B. That's correct. Okay. Okay. Which amateur band includes 146.52 megahertz? Is that 20 meters, 6 meters, 2 meters, or 70 centimeters? C. There we go. All right. What is the FCC Part 97 definition of a space station? An amateur station more than 50 kilometers above the Earth, any orbiting satellite, an amateur station using amateur radio satellites for relay signals, or a manned satellite orbiting the Earth. Thank you. Should we say A? A is right. All right. Okay, get out your Ohm's law, little thingy. What is the current? So we're looking for current through a 100 ohm resistor that's connected across 200 volts. So is that 2 amps, 100 amps, a half an amp, or 20,000 amps? What do we say? Say. There we go.
Just to comment on that. Simple formula to remember always is E equals IR. Watt equals volt times amps.
Yeah, we did the whole circle thing. They got it all good. All right, what is the characteristic of HF communications compared with communications on VHF and higher frequencies? That long distance ionospheric propagation is far more common in HF. HF antennas are generally smaller. HF accommodates wider bandwidth signals, and there is less atmospheric interference or static on HF. What do we think? A is right. Well, the other ones are actually opposite wrong.
Right.
So, all right.
As long as
What?
I picked up, I figured. Okay, never mind.
Okay. It's all right.
That's gonna be worded like that exactly, so I don't
Yeah.
know.
All right. There you go. Hey, what are the names of the electrodes of a bipolar junction transistor? A. It's easier if everybody just reads it. Have me read everything, right? Which of the following results from the fact that signals propagated by the ionosphere are elliptically polarized? We got a couple more A's than I have C's, I think. So who says A? Okay, 3 A's. Anybody else? C? I think A is the right guy. Yeah, again, the only time really when the transmit receiving stations need to be the same polarization is typically for like line of sight, FM type stuff, right? Okay, what is a relay? E. Taught you guys well. Right, what is a common repeater frequency offset in the 70 centimeter band? Great. And which of the following restrictions apply when a non-licensed person is allowed to speak to a foreign station using a station under the control of a licensed amateur radio operator? E. So why are simplex channels designated in the VHF and UHF band plans? So what's the vote? How many say A? How many say B? C? Or D? So you got a couple of D's. That's right. Yes. Okay. So under which of the following circumstances are one-way transmissions by an amateur station prohibited? C is correct. What does the abbreviation RF mean? A. All right. What is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz?
Like, doesn't says A, that's what.
Yep, that was one of the examples. I said I put them in there because there are questions on them. Right. What is a talk group on a DMR repeater? C. Right. How does RF radiation differ from ionizing radiation, like radioactivity?
Seats.
Correct. What's the characteristic appearance of a cold tin lead solder joint? Let's see, how many say bright and shiny? About excessive solder, dark black spots, or a rough lumpy surface? Yeah. Yeah, some of the answers, usually one or two are really wrong. One's kind of right, and one's more right.
Done enough bad knowledge in my life.
Yeah, okay.
Sorry. Oh, yeah.
Yeah. My kid brother used to tell me, I'm a pain. I'm not a window pane. So how is over the air access to IRLP nodes accomplished?
Oh, no, D.
Final answer? D. All right. Why are short, heavy gauge wires used for a transceiver's DC power connection? Right. What types of international communications are an FCC licensed amateur radio station permitted to make? Which of the following causes failure of coaxial cables? Okay. Go. What is the name for the flow of electrons in an electric circuit? The current. What hazard is caused by charging or discharging a battery too quickly? Overheating or outgassing?
Blown up a bad.
Yes, we all have. Unless they're door cells, they blow themselves up. Right. What is meant by check in a radiogram header? Number of letters or number of words or words equivalents? Yes. Which of the following are required for remote control operation? They're all right, but one's more right.
Remote. Control point. Sorry. I guess the control point's considered wherever the operator.
Yes.
Okay.
Wherever the transmit can be enabled and control the equipment can actually be done. So a lot of people will actually set up a radio, maybe at their summer house where they can put a bigger antenna up or something like that. And when they're home in the city, they can connect over up to it and control it wherever they are. What's the function of the single sideband CW and FM switch on an FM, or excuse me, on a VHF power amplifier?
Okay.
Is it C or D? Okay, here's one that had the schematic here. What component is number 8 in this diagram? I'm not even going to show you the answers. Tell me what it is.
Like
The light emitting diode? C, right? Point, right. What property of a radio wave defines its polarization? I only said it once, so like
I think
it is D, the electric field. Right, which of the following are inputs to a satellite tracking program? Clearing of elements. Okay. Which decibel value represents a power increase from 20 watts to 200 watts? MdV. Right. What is the minimum safe distance from a power line to allow when installing an antenna? 10 feet. Why is coaxial cable the most common feed line for amateur radio antenna systems? So I heard a couple of C's. It actually does not have less loss than there's other types that are lower loss, but they're a little bit harder to handle. Yeah, so like window line twin lead is actually much less loss, so than coax is. So what would cause broadcast AM or FM radio to receive an amateur radio transmission unintentionally? Or D. Okay. And which type of modulation is commonly used for VHF and UHF voice repeaters? C. I heard C. All right, last question. What electrical component stores energy in an electric field? Right, exactly. So C is an inductor, that's magnetic energy. A is. So we all passed collectively. Okay. How'd you do individually? All right. We'll run another one, or does anybody have any questions? Anything you want to ask before we start a second one?
The F and the PM one, I didn't get. Sorry, it was the.
Oh, for the most common transmission mode for repeaters.
Yeah.
It's really FM, but FM and PM are really pretty tightly related. And from all practical purposes could be received the same way. But FM is the reason that FM is there, that's what makes it the right answer. Okay. Any other questions before we start another one? Is this a good format for this? All right, let's do another one. All right. What is the type of transmission as indicated by the term never twice the same color? NTS. D. All right. What are the names for the electrodes of a diode? Okay, anode and cathode. Who's responsible for ensuring that no person is exposed to RF energy above certain exposure limits? Right. Your station, you're responsible. What is the electrical term for the force that causes electrons to flow? Voltage. All right. What is required when climbing an antenna tower? Okay. There. Is that an answer? All of them are right. One answer is more right. What causes tropospheric ducting? Or B for inversions in the atmosphere. When under normal circumstances may a technician class licensee be the control operator of a station operating in an amateur extra class band segment? Or D at no time? So he could be operating, but he can't be the control operator. He can come in as a guest, like third party type thing, but not be the control operator. What might be a problem if you receive a report that your audio signal through an FM repeater is distorted or unintelligible? So we got all frequency, bad location, batteries running low, or all of them. How is a voltmeter connected to a component to measure the applied voltage? A. All right. Which of the following self-assigned indicators are acceptable when using a phone transmission? Yep. What's the approximate length in inches of a half wavelength 6-meter dipole antenna? Without doing the math, you guys are good. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? A. Yeah, this one would say, well, if you looked at this, you multiply it to 13.8 times 4, that gives you just something just over 50 watts. But a 50-watt transmitter is going to use a lot more than 50 watts of power. So that's why this one's the right answer. Which is equal to 1 kilovolt? Which type of voice mode is often used for long distance or weak signal contacts on VHF and UHF bands? Sideband. What is a way to enable quick access to a favorite frequency or channel on your transceiver? Stored in a memory channel. If your license has expired and is still within the allowable grace period, may you continue to transmit on the amateur radio bands? Only one answer says no, and that's right. Which of the following is required when making on-the-air test transmissions? Let's identify. Which of the following are provided by a satellite tracking program? Which of the following is good procedure when contacting another station within a contest? What hazard exists in a power supply immediately after turning it off? What was it? What did I hear? All right, that's by the cat. Who selects the frequency coordinator? We just talked about this, right?
Yeah, it's the amateur operator that will. Oh, like this.
There you go. All right, what is component number 3 in this circuit?
That's
That's a lamp. It looks like an LED drawing, but it's not the LED symbol, right? It's a draw. It's actually the symbol for a lamp. What type of circuit controls the amount of voltage from a power supply? Regulator? Regulator's right. What type of signaling uses pairs of audio tones? Right in the name. Dual tone, multi-frequency.
No phone.
Yep, exactly. That's where it comes from. Yep. Each of the A and B's, each row and column is a different tone. The combination is dual tone, multi-frequency. What electrical component is used to protect other circuit components from current overloads? Fuse. Or fire. All right, which of the following frequency ranges are available for phone operation by technician class licensees? Another one you just got to memorize. All right, so what do we think, guys? A? All right, good job. What's the relationship between wavelength and frequency?
Yes.
So B is right. What happens when antennas at opposite ends of a VHF or UHF line of sight radio link are not using the same polarization? Right? And when do FCC rules not apply to the operation of an amateur station? Well, FIBA rules, FCC rules, when operating a racist station or operating an area station.
Rules always apply.
What does a dummy load consist of? All right, how many say A? We got one A. How many say B?
It's,
How many say C?
it's. That's the oil thing. It's listed.
Because A and D are pretty close.
Yeah, actually, I'd go with A because Z is an implementation.
Okay, but are all transmission lines 50 ohms? All the ones we talked about were 50 ohms, but they're not all 50 ohms. I actually don't know which way this one will go because I don't know what they're trying to imply here, because really they're both right, right? But not all transmission lines are 50 ohms. But whether that you're really supposed to know that at this point or not, we'll see. So I would actually probably go with D. But which one do you want to do?
D.
Yeah, exactly. So what is the voltage across a 2 ohm resistor if a current of a half an amp is flowing through it?
C.
C? C is right. How much power is delivered by a voltage of 12 volts and a current of 2.5 amps? B? Right. Right. What can cause erratic changes in SWR, standing wave ratio? Right. Which of the following is used to convert a signal from one frequency to another? Mixer, right. How does the FCC define broadcasting for the amateur radio service? A. So, right, so A is right. Broadcasting is everybody else, even though when you're making a contact, you're actually sending out a signal, but we don't call that broadcasting. Broadcasting is kind of an intended to a wide audience. So we collectively got 100% again. How did you do individually?
26, right with that?
Yes. 26 out of 35.
Okay.
All right. Ready for another one? All right. Which is, again, you're just getting a free look at the possible questions that you might have on your exam here too. So just, like I said, the questions will be worded exactly the same way. The answers might be in a different order. Okay. All right. So which of the following is combined with an inductor to make a resonant circuit? Right. Under what circumstances is it safe to climb a tower without a helper or observer? Oh, they're laying on the ground. You can't, that's not one of the answers. What's the primary purpose of a dummy load? Right. When may amateur stations transmit information in supporting of broadcasting, program production, or news gathering, assuming no other means is available?
Is it the broadcast? Well, it's talking about program music production, so I guess that doesn't speak.
Well, in support of broadcasting, program production, or news gathering. Which doesn't sound like it's, well, so that, again, it's one of those things that to me doesn't sound like safety or human life, right? So I would think it's never. I don't like that one. So I guess they do want, so that's I said, some of these are a little tricky the way they're worded, right? So B is the right answer, actually. But when was the last time you saw the news save somebody's life? I don't know. So who may select a desired call sign under the vanity call sign rules? Any license? Well, actually, it's any licensed amateur can request a call. It just has to be in the format that your license type is. So.
Vanity, second vanity.
Oh, yeah, that my call is a vanity call sign W2 AEW, and but as long as my license class allows me to have a 1x3, I can select that call, right? But if you're as a as a technician, your calls are only 2x3s. You can't select a vanity call sign that is not a 2x3 format. All right, what type of switch is represented by component number 3?
Single poles.
Single pole, single throw. What should be done to all external ground rods or earth connections? Bond them together with heavy wire or conductive strap. How can you make sure your station stays in compliance with RF safety regulations? So I heard D. Right. In which direction does a half-wave dipole antenna radiate the strongest signal?
Broadside.
Broadside to the antenna.
Let's take the Yagi. It's like, think
Yep.
of it that way.
Exactly. Yeah, a Yagi is just a collection of dipoles, right? That's the way to think about it. All right, component number 9 in this figure.
Variable.
Variable resistor, which is also called a potentiometer, but we have the variable resistor answer. Which of the following should be considered when selecting an accessory SWR meter? Frequency and power level at which the measurements will be made, yes. What is the resistance of a circuit that draws 4 amps from a 12-volt source? 3 ohms. Which is equal to 2,425 megahertz? C is right. What type of transistor has a gate, drain, and a source? The bipolar is base, collector, and emitter, right? So FET, field effect, is the one with the gate, drain, and source. Okay. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? All right, choke is right. When configured to measure current, how is a multimeter connected to a component? D in series. Remember, current is always going to flow the same to things in series. Why are simplex UHF signals rarely heard behind their radio horizon? Right. Except for those half a dozen weird modes we talked about. What is the approximate bandwidth of a typical single sideband voice signal? So 3 kilohertz is right. But exactly. Yep. Yeah, remember that for when you do AM, you get the carrier and your voice sidebands, right? Your voice is up to about 3 kilohertz. So you eliminate the carrier and the other one, you're left with 3 kilohertz. What is the impact of using excessive effective radiated power on a satellite uplink? So blocking access by other users. So what are the what's the consensus here? B is right. What would cause your FM transmission audio to be distorted on voice peaks?
That's why A seems weird. That's not the transmit power system.
Right. Yeah. On remember FM, the amplitude doesn't change with your voice, right? Just the deviation that changes with your voice. So if your voice peaks, where you're talking, where the loudest portions of your voice, that's what's supposed to be. Right. Why should you not set your transmit frequency to be exactly at the edge of an amateur band or amateur subband? So that one's right.
Yeah.
So C, so they're all right. Which agency regulates and enforces the rules for the amateur radio service in the US? Right. What is an ARQ transmission system? An error correction method, which the receiving station detects errors and sends a request for retransmission. Which of the following must be programmed into a D-Star digital transceiver before transmitting? All signed, right? What describes the number of times a signal that a second that an alternating current makes during a complete cycle? What is the unit of impedance? Ohm. When using a directional antenna, how might your station be able to communicate with a distant repeater if buildings or obstructions are blocking the line of sight direct path? D, binary path that reflects the same as the repeater. What are the two components of a radio wave? Electric or magnetic fields? Which of the following methods is used to locate sources of noise interference or jamming? Direction finding. Which of the following is a source of loss in coaxial feed line?
All the same.
Are all the answers correct?
Yes.
Yep. What is the function of a transceiver's PT2 input? Okay. What is a band plan beyond the privileges established by the FCC? Voluntary guideline, gentlemen's agreement. What is RACES? Yep. Who must designate the station control operator? Okay. Last question. Which of the following is a requirement for the issuance of a club station license grant? There we go. We missed one, but all right. Let's see. So we're about 10 of. Let's throw another one in. Which of the following bands may provide long distance communications via the ionosphere's F layer, F region, during the peak of the sunspot cycle? 6 and 10s, right. What is a disadvantage of the short flexible antenna supplied with most handheld radio transceivers compared to a full-size quarter-wave antenna? D. What is CW? What is required before using the Echolink system? Third A. That's right. What electrical component opposes the flow of current in a DC circuit? Which of the following indicates that a station is listening on a repeater and looking for a contact? Remember we said it's a repeater.
Oh, it's not a computer.
Yeah. Enter B now. Yeah, generally, CQ is reserved for HF for the most part. repeaters, you generally don't do that. You'll say you're monitoring or maybe monitoring on a certain machine. What information is contained in the preamble of a formal message traffic? All right, in the United States, what circuit does black wire insulation indicate in the 3-wire 120-volt cable? It's black is the hot. Which of the following types of signals has the narrowest bandwidth? Or DCW? What's the grace period for renewal of an amateur radio license? 2 years. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? I heard C. Okay. Which of the following is a reason to use shielded wire? C. Is right. Which of the following can damage a multimeter? Yep, something to measure voltage and use a resistance setting. Yep. What's the purpose of the color code used on the DMR repeater system?
See,
I heard C and D. What are we going to vote for?
you're talking about plug.
D is right. How may amateurs use the 219 to 220 megahertz segment of the 1.25 meter band? What type of current flow is opposed by resistance? I heard all. All is right. Which is equal to 500 milliwatts? Well, I'm hearing different answers. What are we voting for? I heard a couple more A's. A is right. So, there you go. Which of the following can provide power gain? Or D, transistor? Transistor can be used as a switch or an amplifier. Which of the following is an important safety precaution to observe when putting up an antenna tower?
I guess when putting it up, so I guess it's.
Yeah.
Yeah, D. Yeah. Yeah, a ground strap isn't going to help you.
You're putting,
The ground strap on your wrist isn't going to help too much. What's the effect of fog and rain on signals in the 10 and 6 meter bands? Little effect. What, if any, are restrictions concerning transmission of language that may be considered indecent or obscene? Oh, is that like George Carlin's 10 dirty words or whatever? Everybody remember that skit? B?
Yes.
B is right.
So Does that change over time? It's like some things become less seen over time.
Yeah, I guess it gets somewhat subjective over time, I would imagine. Which term describes the ability of a receiver to detect the presence of a signal? Sensitivity. What method of call sign identification is required for a station transmitting phone signals? D. Can use phone or CW. Some people actually have transceivers set up with automatic IDers that send their call sign every 10 minutes on Morse code, even outside of their control. What is impedance? Opposition to AC current flow. Right. What is the definition of duty cycle during the averaging time for ARB exposure? D. Which of the following can be used to enter a transceiver's operating frequency? Keypad or VFO? That's right. Why do most solid state transmitters reduce power as SWR increases beyond a certain level? A is right. What's the approximate velocity of a radio wave in free space? 300 million meters per second. And how many operator primary station license grants may be held by any one person? And what is meant by the statement that a satellite is operating in U/V mode? Right here, D.
It's transmitting ultra. Receiving.
VHF. Okay, UHF and VHF, yep. What's the resistance of a circuit for which an applied voltage, 12 volts, and the current flow is 1.5 amps? So what's the formula?
E and R. So 12 volts.
Well, we're looking for R. So if we're looking for R, the equation is what?
25, that's the
So it's
18.
18. 12 divided by 1.5.
Oh,
Ooh.
Eight, it's eight.
Check your math.
Yeah.
I said all the answers are going to have, especially all the other ones with math, are going to, every other way you can manipulate the numbers are going to be the other answer. So you got to be kept sure of the formula. So, all right, what component is number 3 in that circuit? Variable inductor. Right. Now, what's the major function of an antenna tuner or antenna coupler? Yeah, it does sound right, doesn't it? Now, what does the FCC presume to be the control operator of an amateur station unless documentation to the contrary is in the station records? Station licensee. Okay, last question. How are the transceiver audio input and output connected in the station configured to operate using FT8? Audio input and output to the computer running WSJT software. Yep. All right, one wrong again. So we're all doing pretty good. Everybody feeling pretty confident so far? Getting there? Couple more? More exposure to questions? All right. What technique is used to ensure that voice messages containing unusual words are received correctly? Spell the words using the standard phonetic alphabet. How does the allowable power density for RF safety change if the duty cycle changes from 100% to 50%? If you're transmitting less, so the allowable power density,
All out.
okay? See how it's worded. Which of the following types of antennas offer the greatest gain? Yeah. What is generally the best time for long distance 10-meter band propagation via the F region? So from shortly after sunset to dawn, from shortly after sunset to dawn during periods of high sunspot activity, from dawn to shortly after sunset, high sunspot. What do we think?
I thought it was
So the higher frequency bands, basically 20 meters and above, work better during the day. So, and then obviously at higher sunspot cycles. So that'd be the answer. The lower bands come alive at night. What type of electrical component consists of the conductive surfaces separated by an insulator? Capacitors. Which of the following devices or circuits changes an alternating current into a varying direct current signal? Rectifier. Who may be the control operator of a station communicating through an amateur satellite or space station? So any amateur allowed to transmit on the satellite uplink frequency? Is that right? How can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? It's when your amateur station is causing some fundamental overload in a receiver or a radio. See? Right.
all the. Hostile.
Yeah, assuming that the receiver is getting interfered with is being affected by your transmitter, not by something else that your transmitter's doing. Your transmitter's doing the right thing. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? So 120 divided by 80 is 1/2. Okay. You are allowed to use a calculator for that stuff. When must the station and its records be available for FCC inspection? B. The abbreviation for megahertz. Okay. H is always capitalized because it's the guy's name, and then the capital M is mega. When may an amateur station transmit without identifying on the air?
Oh, yeah.
D is correct. What term describes the use of a subaudible tone transmitted along with normal voice audio to open the squelch of a receiver? Continuous tone coded squelch system. What is the effect of excessive microphone gain on single sideband transmissions? Distorted transmitted audio, right? What is Doppler shift in reference to satellite communications? So, right here, B or D? D, delta. Right, phonetic alphabet. What do the FCC rules state regarding the use of a phonetic alphabet for station identification in the amateur radio service? Encouraged. What is standing wave ratio, SWR? That's correct. What frequency range is referred to as HF?
Hey.
3 to 30. Which instrument would you use to measure electric potential? Voltmeter. What is meant by repeater offset? Yes. What does an SWR reading of 4.4 to 1 indicate? It says match. Which of the following can result in a revocation of the station licensee or station license or suspension of the operator license? That is right. All about the email. Which decibel value closely represents a power decrease from 12 watts to 3 watts? Right, that's a factor of 4, and it's going down, so it's minus. Which of the following VHF or UHF band segments are limited to CW only? It is right. What is the name of an electrical wiring diagram that uses standard component symbols? What is the Internet Radio Linking Project, IRLP? Right here, D, technique to connect amateur radio systems such as repeaters via the internet. Using voice over IP, that's right. Electrical power is measured in which unit? Watts. How can you determine the length of time that equipment can be powered from a battery? I think we talked about this, so let's see what you think. Divide the battery amp hour rating by the average current draw. What's the purpose of safety wire through a turnbuckle used to tension guy lines? What about here? B. Which of the following describes DMR? Yeah, so DMR, one of its features is to multiplex voice signals onto a single 12.5 kilohertz channel. What is the approximate bandwidth of a VHF repeater FM signal? Okay, so how many say A? How many say B? Tentatively. How many say C? And how many say D? The correct answer here is actually B. Okay. So less than 500 hertz, that's more CW. 150 kilohertz, that's more FM broadcast. Okay. So there you go. All right, 4 more questions. Where is an RF preamplifier installed? An antenna and a receiver. So the term preamplifier kind of indicates really low level signals, so it makes sense that it would be here. What is a likely cause of irregular fading of signals propagated by the ionosphere? Are you sure about B? What do you think? I'll try B? A?
I still think
Still think it's B? Right. See it? Try the food. What causes a light emitting diode to emit light? Forward current. Final question. Where should a lightning arrestor be installed in a coaxial feed line? B? All right. Doing okay? Feeling confident? Pretty much.
depends on the test.
Depends on the test. Well, like I said, like I said, there was going to be, for each section, if you will, of the, each category of questions, there's only going to be 1 or 2 questions in each category. So if there's a category that's a little bit weaker on, you can kind of be saved by the others. Okay. Let's see where we are time-wise. So we got 3:12. Want to do one more, or how much time you guys need?
Check the walkthrough there.
Take your time, whatever you want.
All right. You guys feel like you want to do one more? And then you'll let you guys go? All right, last one. All right, which of the following types of feed line has the lowest loss at VHF and UHF frequencies? Air insulated hardline. And so the antennas get smaller, but the feed lines get bigger. Why is the radio horizon for VHF and UHF signals slightly more distant than the visual horizon?
Yeah, right.
The atmosphere refracts radio signals slightly. What should you do before calling CQ? Listen first, yes. All the questions. There's one of those deals, all of them are correct, right? There you go. I read it too fast too. What factors affect the RF exposure of people near an amateur radio station antenna? Frequency and power, distance, all these choices, and radiation pattern. All these choices. Yep. Okay. What is the Radio Amateur Civil Emergency Service? Say D. Correct. What is the meaning of the term picket fencing? How it sounds. In which type of circuit is voltage the same across all components? Parallel. What is a beam antenna? Antenna concentrates signals in one direction. No offense to parents beam. Why should a 5 ampere fuse never be replaced by a 20 ampere fuse? Unless you want things to get exciting. What is a transceiver? Device that combines a transmitter and a receiver. Which of the following battery chemistries is not rechargeable? Carbon zinc. Also known as a primary battery. Which sideband is normally used for 10-meter HF, VHF, and UHF single sideband communications? Upper sideband. Which is equal to 1,000 picofarads? Unit conversion here. 1 microfarad. Good job. How much current is required to deliver 120 watts at a voltage of 12 volts DC? 10 amperes. Which of the following is an application of APRS? real-time tactical digital communications in conjunction with a map showing location of stations, yes. Who is accountable if a repeater inadvertently retransmits communications that violate FCC rules?
Oh,
What do we think?
we can still see.
We could see. There we go. All right, component number 4 in this diagram. Transformer. One of the answers even. Look at that. Okay, which Q signal indicates that you are changing frequency? Yes, why? What signals are used in the computer radio interference for digital mode operation? Or excuse me, interface. What signals are used in the computer radio interface for digital mode communications? How is a voltmeter connected to a component to measure the applied voltage? Parallel. Which of the following is standard practice when you participate in a net? We said A and I hit B. Sorry, that was my fault. Which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? Or band reject filters, right? How is a specific group of stations selected on a digital voice transceiver? C. Correct. What frequency range is referred to as VHF?
Megahertz. Yeah.
30 meg to 300 meg? Okay, very good. Which of the following protocols enables an amateur station to transmit through a repeater without using a radio to initiate the transmission? Echolink, right? And which instrument can be used to determine SWR? Directional operator. When is it permissible to transmit messages encoded to obscure their meaning? A. A is right. Which amateurs may contact the International Space Station on VHF bands? B. Which of the following is true when installing grounding conductors used for lightning protection? Sharp ends must be avoided is correct. Which of the following components can consist of 3 regions of semiconductor material? The transistor. Right. How soon after passing the examination of your first amateur radio license may you transmit on the amateur radio bands? Is your appear in the database is correct. Which of the following is an example of remote control as identified in Part 97?
C.
And what component changes 120 volts AC power to a lower AC voltage for other uses? Transformer. Why are metals generally good conductors of electricity? Free electrons. Well, last question. What is a satellite beacon? Okay. Right. Okay. One misclick for me, but otherwise you did pretty good. All right. All right, so it's 3:21. Let you guys take a little break, breather, come back, start getting the paperwork done, and I wish you all good luck.